All right. Back again for more of Odinmade Hero. Yet again, I have to check to make sure that everything's actually working and triple check that I've got my audio set up right so I don't start off clicking in everybody's ears with my busted audio. But yesterday was a good day. I almost had to end the stream with a bad bug in place. And then, by the skin of my teeth, I was able to figure out what the issue was. And so now, we've kind of moved this tile map code into a bit better of a state. But now, I think today, Casey's going to show us how to virtualize that tile addressing so that we can store a nice big game world in all these different tile chunks across many different tile chunks. So that'll be our task today. But real quick, I did want to say, hey Devil, hey Santos, I did want to say thanks to those of you who have been watching. So those of you who are already here watching this live, but also everybody that's been following. I know I haven't been addressing the follows as the days have gone by, but there's a bunch in here that we've picked up over this last week. Rad, One Cal Dad, Oni Axis, O Twitch D, Andrew, Sanic, Avalanche Pointer, Mr. Intrinsic followed, Stowe, Jace with the Prime subscription the other day, thank you. ACJ, Mr. Ed Makes, and Jindra the Third. Thanks to all of you for coming on this journey with me. And that's just on the Twitch side. I don't know about YouTube because I don't have like a list in front of me. I should probably get one for people that are subscribing to the new YouTube channel, but we have been picking up more subs over there, so thanks to those of you that are following. I am paying attention, and I acknowledge you, and I appreciate you, but just because I don't want to get too sidetracked. I get sidetracked enough. Oh, great. The stream is dropping frames. Lovely. Okay. See, I get sidetracked enough with technical issues and just my own thoughts, and I'm trying to be very disciplined about staying on track towards the thing that I want to do, right? It's hard enough when every so often we get a stupid internet issue. It could be because of this bad weather. I'm really not sure. It's terribly windy outside, and it's just weird how fast it changes because we had, you know, days that felt way too hot just a week ago. And I would be inside sweating all day at my desk because the office would get so hot. And now I can barely feel my fingers. My hands are so cold. But anyway, so I do appreciate it. Thanks to all of you. And we'll keep on moving forward and trying to do something awesome here on stream eventually, one day at a time. So I'll go ahead and tab over to Casey, and he can get us started.
Okay, hello everyone, and welcome to the morning edition of Handmade Hero, the show where we can code a complete game from scratch, no libraries, no engines, so we can see the entire process and learn about absolutely everything that happens in the full pipeline of a game, right down to how every single pixel is drawn. We are at the point where we are experimenting with our sort of game, what it's going to need. We're basically making some little debug stuff where we can move like a little rectangle around the tile map and do some stuff with it so that we can kind of define what our engine architecture needs to be. And basically the way that I always do architecture as much as possible is I write the code that uses what I'm going to make first without it being there. So I just pretend that I have stuff that does whatever I want, and I hack something together that sort of makes it work. And then when I'm satisfied that that sort of like definition of what it needs to do is good and works well, then I kind of break it off and say, this is the design, this is what the sort of API, the interface needs to be to that part of the code. And then I can go start making it for real and doing sort of an industrial strength engineering job on it. So that is the point that we're at. And so I'm going to go ahead and dive right in because we have some stuff that we wanted to finish up from yesterday around basically how we're structuring our tile map interface. So I am going to get right into that. If you are following along at home, if you pre-ordered the source code on handmadehero.org using the handy dandy pre-order button, you should have gotten a link in your email. If you click on that link, it will allow you to download the source code in a zip file. That zip file has zip files for every day. You are going to want to unzip day 32 because we are on day 33 right now. And so you always unzip the previous days. So unzip day 32 and you will be exactly where I am in the source code if you would like to follow along at home with the video. So let's go ahead and...
Thankfully, this whole time we've been working on our whole own code base, so I don't have to do any of that, but you can. It's a totally reasonable way to follow this series, I think, rather than like actually hand coding it all while watching. You could easily just kind of look at what the changes he's making in the areas of the code where he's making it, and that would probably be less work, but then you'd learn less. There weren't any interesting points of conversation in the previous day's Q&A, but he did go over one thing, which was that in the main program that calls the game code over here, there was something about the fact that when replaying the game state, so specifically when we're doing this here, we hit record, and then we just start recording the gameplay, and then we play it back. There was a point that he made about how we only needed to store a very small slice of the game's transient storage after putting in all of this work to get that store to run quickly. You know, he's storing a whole gig essentially and then playing it back. And on that first write to write the game state to disk and then, you know, read it back on the game state playback, it was a bunch of effort that he put in, and it wound up not being necessary, right? Because he only wanted to write out the part of the game state that needed to be played back. So that's where this to-do over here comes from. Transient storage needs to be broken up into game transient and cache transient, and only the former needs to be saved for state playback. So this part right here, the game transient storage and not the cache transient storage, if I can speak right. And I think, you know, it's like an instance of where he feels ultimately where this series wound up and how he feels about it is that notion of spending all that time to figure out how to write that thing out is somehow wasted time, or it was not something that should have been in in the series at all. You know, like that whole day, you should be able to just skip past that whole day. But you wouldn't know that unless you'd seen him experience that. I keep coming back around to this, and it's the fact that making a mistake, you learn more from making a mistake than you do from just doing things right the first time. And there is something to be said for not having your head filled with a bunch of bad ideas of doing something, because then that colors your notions of what the right way to do something is. And then, you know, when you do see something being done the right way, you're skeptical of it, maybe because it looks too easy. I don't know how to feel about it, because watching him make those mistakes tells me it's okay. It's that much more reasonable that I make my own mistakes. So I keep contending with that, and I keep, you know, I can see both sides of it, where I understand where the idea of making a version of this series that isn't 600 days long and doesn't have a lot of that, you know, failure in place to get to the thing that you actually want to build. Like, for instance, in the game code, we still have all of these separate members for X and Y instead of using vertexes. But I think that evolution of problem solving is still important to see, and that is the original spirit through which he intended this series to be done. So I just keep coming back to that. It's these two themes that are, you know, at odds with each other, doing what is the right thing to do. We have to figure out what the answer is. Siri, shut the hell up. We have to figure out what the right answer is. Otherwise, how are we ever going to do the right thing? But you got to fail to get to that point. So it's just a tough thing to really, you know, sit down and say that all of this work, you know, this very dense work is somehow unnecessary, because if you're just hand-fed the information that you need to go do the right thing, you're skipping a lot of steps to get to that place of like realizing and being able to recognize this is the right thing. Yes, everybody does make mistakes. We've gone over this before, but we'll keep on bringing it up, I guess, as often as necessary.
Here to Handmade Code. Here we are. Let's start up our editor and our debugger. And if you remember where we were at, we basically had it so that we were running our little dude around, and we had just finished making it so that all of our units for the guy's motion were in sort of, we moved them basically out of pixel space. We moved them into real space so that everything's happening in meters inside the game, and then it only translates them out into pixels when it's time to render. And this was important because we want to support basically any resolution of the game. We don't want everything to be hard-coded in pixels, so that is why we were doing that. So what I want to do now is start to work on the tile map structure a little bit, because I said that there was some stuff in there that I wanted to do. We talked about it yesterday. So there were two things. And one thing that I wanted to do was I wanted to change to a math-friendly coordinate system. So one where y goes up and x goes over, you know, the standard coordinate system. And right now we're not doing that. We've got y going down because that just happens to be how our bitmap was set up, right? That's about it. And so similarly to that, I also want to make it so that our tile map is accessed in a more sort of coherent way that I talked about, and we'll cover what I want to do with that again. I'll just a brief refresher. So I want to do those two things today if I can. So basically all we really need to do is just flip everything upside down to make our y go up. We haven't defined any real information about the maps or anything like that. So we should be able to do that pretty easily and start to think about what it means to have our stuff flipped upside down in that sense relative to the bitmaps. But I'm not sure which order I want to do them in. So I'm going to go take a look at the code and see whether I want to flip things upside down first and then do the tile map stuff, or whether I want to do the tile map stuff first and then flip up things upside down. I'm not sure. So let's go take a look at where we're at.
One second. I just need to step away for a moment. Forgot I need to do something. All right, sorry about that.
Inside our handmade.h here, we have this canonical position structure, which now we've kind of worked it down to the point where it can sort of be considered a world position. And so one of the things that we were going to talk about is possibly just renaming it from canonical position. And I think that's a reasonable thing for us to do just right off the bat. We can replace canonical position with world position, and we shouldn't really worry about that anymore, because there's only going to be one world position struct, and that's just a trivial change to make. So that's pretty easy to do.
Okay, so all we just did was take this idea of a canonical position and reconcile it with the fact that this is really just meaning the world position. So really easy to knock that out. Just get rid of every single reference to a canonical position and replace it with world position. Make sure that still builds. And we're good.
And yeah, and so let's do it. Now, to flip y to going up, obviously I could easily flip y. I could easily flip these two. These are just offsets from a tile. I could easily flip y from going up here. But the other thing I want to do is potentially make it so that they're based on the center of a tile. We could also do that. I'm not sure which of these we want to do, like I said. If we wanted to switch y to going up, and everything from being the lower, right now, if you remember, oops, didn't mean to do that. There we go. If you remember, right now, when we're talking about a tile, we use the upper left corner, and we create an offset from there to say where somebody is relative to the tile. And then if they move out of the tile, we start tracking them in the next tile over, and we use the upper corner of that tile to say where they are, right? And so what we could do is we could switch inside the tile to being from the lower the lower left corner instead of the upper left corner, and that would flip the direction of all of the guys' motion properly. But the tiles would still go in the wrong order, right? The tile Y would still be going down as you went down, so we would also have to flip that. I'm guessing that probably the right thing to do, since we have this working, is to maybe just go ahead and actually think about flipping this actually go ahead and flip this with what we have right now. So let's look at what it will take to do that. So first of all, we defined these maps, and we defined these maps the way that we type them in here. We defined them upside down if we were to go bottom up, right? If you think about the way we wrote it in the code, the first row in the array is at the top. And this makes sense because we're defining it in ASCII where we're going from top down, right? So, you know, if we were to switch it so that y was up, then the first row that we drew at the bottom of the screen, right? Because remember, if we start drawing, you know, if we were to start drawing tiles at the bottom corner of the screen, this is the 0, 0 tile all of a sudden. Well, the 0, 0 tile in this array is up here, right? So this would be flipped upside down. All of these prefab tile maps that we created would be flipped upside down. And since we're actually, I mean, we're not wedded to this. We didn't really spend any time making anything meaningful here, so we could just flip these upside down, but it's worth noting that that's what would happen, right? Our entire tile map would be flipped upside down. So for example, and we could do that right now, actually, pretty easily. In our drawing code, right, the only thing that made it so that this stuff drew in the way that it drew for the tiles is the fact that when we started off on row 0, right, that we did the upper left corner, right, plus so this is the x, which would stay the same. The upper left corner is y, plus however many rows down we were times the side in pixels. So this was essentially the way that we were drawing is we started here, and we said the first tile's here, and then for every row we went down, we added however long this was to get to the next one, right? So we're just kind of doing this process on the way down. So if we wanted to invert the way we were drawing, it's pretty darn trivial, right? All we would have to do is say that this now is going to be the lower left, right, from now on. And instead of adding this in, right, we're going to actually subtract the tile side in pixels, right? But in subtracting this min x now, this min y max x thing, right, we actually have to draw from the base up. And min and max is kind of an incorrect terminology now as well, because our coordinate system that we're actually outputting to still has y sort of going down on the screen. So we would actually have to pass the min and max backwards, right? I don't know if you can see what's happening here. So this basically would do the inversion. If we wanted to flip things upside down, we could do that, and it wouldn't be that hard for us to do. So let me just show you what that looks like if we just do that flip right here. Let's set the lower left like that. And so the lower left x is still what it is, but the lower left y is actually now going to be, instead of 0, it's going to be the height of that buffer. It's going to be when the game buffer comes in, and tells us what the entire screen is, we want to start drawing it basically at that bottom corner, right? And so that is this height parameter here, right? And so that that buffer that we get passed in game update and render, basically, if you remember, it takes this, well, let's get sound samples. Where is it? This is what I'm talking about. It takes this off-screen buffer, right? And so what we want to do there is we want to say, okay, that buffer's height is where we're going to start in the lower left corner, right? So that.
Okay, let me see if I can track this properly. So instead of upper left, we are talking about lower left because we want to flip the direction we're going in y. And this means that both of these have to be lower instead of upper. And so the x is the same, which I think he probably already articulated, but yeah, and so instead of starting off from the top of the screen at 0, we have to start off from the bottom, which is the height of the buffer. Okay, that makes perfect sense. Yeah.
That. So that would be where we would start, and then what we have to do is, what's this? Oh, I got to convert that to a float. And then what we'd have to do is when we draw the player, we'd have to...
And I'm calling this a frame buffer, and just like he can't assign it straight across, I have to cast that as well.
Repeat the same math. We're now at the lower left corner. The x.
And then all these other places where we're talking about the upper left, or the upper left x or y, we're talking about lower left x and y.
Computation stays the same, but the y computation is different. We start at the lower left corner. We subtract however far we have to go for each individual tile. So if the tile y00, we're still exactly where we are. Then we go to the relative y, and the tile relative y for the guy now will also be based off that bottom corner, right? And now our guy motion code is busted, but in general we should still be able to see the game. And so as you can see here, like when I'm moving, I'm actually moving backwards. You can't see me pushing the wrong key, but now we flipped our tile map upside down, and so y is now going up, pushing the wrong. See here, but in general we corner, right?
So okay, I see. So this we're subtracting, yeah. So we start at the buffer's height, right? And then we're going up, but we're actually subtracting away from the height of the buffer to treat y in the other direction. But like he's just demonstrating, and oh, I called it low left somewhere. That's right. I made a mental note that I meant to come back and change these to lower, but then I didn't actually change that. Well, like he was just showing, oh, well, this is totally not what he was seeing. So what did I do wrong there? I think this maybe had to be a subtraction. Is that right? Is that correct? Yeah. So now, yeah, so you can see I'm going up and down, but the keys are swapped, and that's what he was just talking about. So cool. I'm keeping up. China.
Right. And now our guy motion code is busted, but in general we should still be able to see the game. And so as you can see here, like when I'm moving, I'm actually moving backwards. You can't see me pushing the wrong key, but now we flipped our tile map upside down, and so y is now going up in our world instead of down, right? And that's, obviously pretty straightforward. There's really nothing else that has to happen in terms of handling the world, because everything works upside down or right side up, obviously. But, you get the idea. So the only other thing we need to do now is fix the guy's movement code, so that the guy's movement code is going to be sending him in the right direction. So instead of using the negative version, so right now I'm pushing down to move him upwards, right? Like I'm pushing the S key to move him upwards. Instead of that, up in our guy movement code, wherever our guy movement code actually was, let's see here. It's one of the things about not breaking things off into functions is I can't use the Alt-J to jump to them. I wish there was a jump to comment, but unfortunately there isn't. Oh, the things that a good editor could do. So anyway, inside our movement code here, right, you'll notice that basically we have things inverted. So ended down from move up and move down are inverted from what they are here. Left and right, it's negative and positive, but move up is negative. So what we'd want to do in our guy movement code, right, is we'd want to move him in the opposite way. And then when we come here, now he's moving correctly around the screen, right? And so now I'm pushing S to go downwards, and off we go. So I think that was the right...
Make sure I actually did the change that I think he just made. I wasn't looking, but it looks right to me. So now my keys are properly mapping to WASD again. We still have this issue where our tile map orientation is reversed, but I can go around in a big circle here and come back to the beginning. Sweet.
Order to do things in, because that was pretty simple to do, and now we're in that order. And now when we do our tile map stuff that we're going to do, we'll just start out in the right coordinate system, and we won't have to rewrite everything, right? So pretty straightforward. Hopefully that made some sense. All right. So it flipped our world upside down, but like I said, we don't care about that yet. Basically, all that means is when we write the code that does our world generation, we will just write it knowing that our coordinate system has y going up, and it will, think about when it's putting a tile above another tile, it will use +1 instead of -1, and we never have to really make stuff in ASCII, so we don't really have to solve the problem that these are backwards from how they appear on the screen. That doesn't really, there's nothing particularly special about that, so that seems like not really a big problem. Okay, so we're chopping through our to-dos here. That's good. Y is going up. Whether or not these should be from the center of a tile is something we can deal with a little bit later, certainly, because it really doesn't have anything to do with anything other than the player movement code. So when we look at the player movement code again, maybe we can talk about that. But basically what we need to do now is we need to start thinking about this, right? And so here's what I want to do. I've said it a couple times, but I think it keeps bearing repeating because, again, it's kind of complicated. It's a little bit of an advanced thing to some degree.
Thank goodness he's doing this.
One more time, just so we're all clear on what's going on. Okay, so what I want to state very clearly is we need a lot of precision as to where people are in the world. So if we were to use 32-bit floating point values, right, which are what we're calling those real 32s in the code, right, and that's type def to be a float, a C++ float, right? That gives us 24 bits of actual data, basically. There's an exponent, there's a sign bit, but we have 24 bits of actual resolution, right? Well, what ends up happening there is, as I explained before, I need at least 8 bits of fractional precision per pixel, right? So for each individual pixel on the screen, I need 8 bits that say how far through that pixel you are, basically. And the reason for that is I want to support the full color range of blending, and colors are 8 bits at least on most modern displays. So when we output colors, we need to output a level of color between 0 and 255. And so when we are alpha blending, and we're talking about where someone is, this is a pixel right here, right? And we're talking about where a shape passes through it. I want to be able to talk about how much of the pixel is covered, x and y-wise. I want to be able to talk about that at 256 steps of resolution, which is 8 bits, because that will make sure that I have full color resolution to do like anti-aliasing and stuff like that. So I need 8 bits. That immediately chops us down to 6 bits of resolution on our floating point value, right? 16 bits of resolution is 65536 pixels, right? Because this is fractions of a pixel, because I took the 8 bits for that. So we have 65,000 pixels, right, of resolution before I start to lose resolution, and I lose some of this. I lose some bits here. I lose bits in terms of my rounding. So if you imagine the guy starting out at 0, 0 in the world, what I want to talk about, like I said, I've said this again, but how far can he move from 0, 0 along x or along y before I run out of this precision? Well, like I was saying before, we know that a screen on an HD display is going to be like at least 1920 across in x, right? And displays are getting even higher res than that, so that's being generous. We may want to run Handmade Hero at a higher resolution at some point than that. So 6.
And it's a good point too, because he might be using 1080p monitors at the time of when he did this series, right? But I'm on 1440p with these, and this is actually lower than where I want to get to ultimately, because I would really like a 4K display. I just haven't been motivated to spend the coin on such a thing quite yet.
5536 divided by 1920. You can see that basically we have 34 screens that we can go in this direction, right, before we lose precision. So 34 screens in that direction, we'd have 34 screens in this direction, which means the maximum span of our game world would be 68 screens, right? At 68 screens, I don't know how long does it take to walk across the screen. I'm trying to imagine a game like Legend of Zelda. It only takes a couple of seconds, maybe, let's say 5 seconds to walk across the screen. So I don't know, just doing a ballpark, if the max I could have was 68 screens, and I want to take 5 seconds to go across them, how many minutes is that? Well, it would take 5 minutes to walk from one end to the other, right? That's not very long game time, 6 minutes. Of course, you'd have to clear out the monsters there, I suppose. You know what I'm saying. So we could consider just using 32-bit floating point values to store where we are in the world, right?
I can also appreciate I don't know if it's irony or if it's just, the speculativeness that we'd even be able to make a game that's interesting for more than, or at least 68 screens, right? Like, it would be pretty compelling if I could get a game to be that, to hold your attention and get you that invested in it that you would want to work through 68 screens. I can't remember, like I'm trying to think of a similar game, but I mean, if you think of like Pokemon is all smooth scrolling, but if you think about how big the entire tile map is for like those original Indigo League Pokemon games, sure, maybe it was like 2 or 3 or 4 times as many screens, but it certainly wasn't thousands and thousands. So it's nice that we're going to build the capability to have as many screens as we could ever want, screens worth of tiles. But to think that you could make a game interesting enough to want to hold somebody's attention to actually go and visit each and every one of those screens, that's actually the hard part, right? Or at least it's harder than what we're going to implement here.
We could consider it. It would be a game limitation. We could consider it. I don't really want to consider it because, again, part of the reason for this is to sort of show programming techniques. And so if we just slap some floats in there, we're only showing a technique that doesn't really scale very well. So what I'm doing instead is I want to show a technique that will scale to basically an arbitrary number of screens, something that the player could never walk across. And so what I'm doing instead is I'm going to store what tile you're on as an integer. So I'm going to use a 32-bit integer to store what tile you're on, right? And then, which is what we're doing right now. We're using the tile x, tile y. Now we have a secondary layer here, and that's the part I'm going to talk about in a second. So we have a 32-bit integer that says what tile you're on, right? X and y. And of course our y is going up now, so I have to start drawing it that way, right? So here's y, here's x. And there's a 0, 0 tile, and then there's tiles that go out, and of course there could be 4 billion tiles in any direction, right? And then I'm going to use the 32-bit floating point value, right? That 32-bit floating point value would just tell you where you are inside a tile, which basically gives me way overkill resolution. Now, we really only need, an 8-bit or a 16-bit value for that. But there's no real benefit to it because storing 16 bits for something versus storing 32 bits for something, there's no way to really go in between those very efficiently. You kind of have to pick one or the other. So what I'm trying to do is I want to pick something where essentially I can take 2 things that are on the same screen, change them into floating point values that operate just only in the screen space, and then do everything in 32-bit float from then on. But I want this 32-bit integer for the tile index. I want to have that for storing my canonical positions everywhere so that I can always talk about wherever you are relative to something that keeps the precision. And so what we'll do in general, I think, is we'll take like sort of the stuff that's on the screen, we'll map it all into the space of the screen or something like that, around some center tile, right? We'll map everything into one set of floats for doing all our computations about like, checking where people are relative to each other or that sort of stuff. We can do that mapping once and then do everything in 32-bit float, so we don't have to use doubles or anything like that. And we'll just have this sort of tile index as a thing that we preserve when we're sort of talking about stuff in the permanent storage, so that we never have to worry about losing precision and we can make the world effectively infinitely large, like much larger than a player could ever hope to walk across. 4 billion tiles, obviously, with each tile being 60 pixels. So 4 billion tiles, I don't know how many we said was on a screen, but I think if there was something like 16, so it'd be something like 200 million tiles across, which is a pretty darn big world. Sorry, 200 million screens across, which is a pretty darn big world. All right, so that's basically what I wanted to do, and that's why we're using this system that has multiple things. But if you notice the way we implemented it currently, we have a tile map x and y and a tile x and y, and that gets kind of cumbersome. What I'd rather be able to do is switch to a scheme that's a little more agnostic about that. And also, people were concerned about scrolling. They were saying they didn't like the fact that we were going to use a fixed perspective on things because they thought scrolling would be harder to program and more interesting. So I also am just, for educational purposes, also going to point out that we want to pick a scheme that would work for scrolling as well. So we're not trying to cheat here. I'm going to write this thing as if you could scroll anytime you wanted to. And then that way, if we ever do find that we want to turn on scrolling for some reason, we can. I just don't like scrolling from a gameplay perspective, but that's a separate issue. Anyway, so what I'd like to do now is what we were doing is we were thinking about tile maps.
See, I just watched him explain this for like the 5th time, but I still can't really appreciate the approach of packing everything into single members, other than, I mean, he said it'll make it less cumbersome to work with those coordinates because you can just shift out the parts that you care about to get at the coordinate data that you want to use, whether it's which tile chunk we're on or where in that tile chunk we happen to be in screen coordinates, right? But aside from the fact that I know he doesn't want to have to use doubles because his original notion was I want to be able to ship this to like Raspberry Pi or some architecture that doesn't necessarily have 64-bit floating point, right? So still struggling with the significance of just going this way, other than like I guess if I just take it at face value with the cumbersome aspect of it, the how encumbering it is to deal with 4 different members when you could just use 2. But if you're still having to do an operation on just those 2 to get at the thing that you care about, I don't know just how much easier that is. I guess if you wrap that shift out and then it's like get tile chunk coordinate, and then it shifts out the tile chunk coordinates from the member value, and then get screen space coordinate, and then does the same thing, but it's a different shift value. I don't know. Probably thinking just a little bit too much about it, but I really want to understand the value of why he's doing it beyond just like we can do it. And it's cool to do it, pack that, data in just one member. I guess for the sake of just having less data about the tile map to deal with, like, you have to be at a place in the world, in the game world. And if you can do that with fewer members on the struct that defines that game world, why wouldn't you? I guess. I don't know. We'll see. I'm hoping I'll have that aha eureka moment, like this is so much better this time around, but we'll see.
This is the screen, right? In fact, well, let me make that a little bit bigger. This is the screen. And what we were doing before is we were saying that a tile map is one screen worth, right? That's how we were drawing it. And so then we had like a tile map for every screen, and we indexed those using this. Then we talked about the tile on each individual tile map, which is basically a screen. We used these to index into those. What I want to do now is switch to saying that the screen and the tile maps are unrelated. The screen is just a window into our 4 billion by 4 billion tile map. So we have a giant tile map, and the screen at any given time is just looking at some portion of that world, right? Now, we can't store a 4 billion by 4 billion tile map. There's no way to store that, right? It's not possible. Because if we were to actually store that, if you think about how big that would be, so we have a 4 billion, 1024, 4 giga tiles. It's really giga tiles, right? We have 4 billion, even just to store 4 billion tiles, right, would be, even if it's 1 byte per tile, which we're going to want to store more than 1 byte per tile, I strongly suspect, right there, that would be 4 gigabytes, right? Just 4 gigabytes just for one row of tiles in our tile map. But now we would need 4 billion 4 gigabyte things to store our tiles, which is, there's no way, that's not even possible. You can't even get a hard drive that would store that many, right? Let alone in-game memory for that many. So what we want to do instead is we want to store this sparsely. So if you imagine our 4 billion by 4 billion tile map, here's 4 billion by 4 billion, and
Gigatiles, 1.21 gigatiles.
we imagine we create the world is only going to exist, whatever our world is, it's only going to exist in some small kind of sparse set of things, right? And so the game doesn't need to store all of that empty space. We just want to make sure that it could be as long as it wanted in any direction and doesn't have any constraints on that. So we just want to make sure that we can store it all. So what we're going to do is we're going to partition it into tiles, like our tile map system from before. But instead of making them screens, they're just going to be arbitrary chunks that are however big it happens to be for efficiency, right? And then we're only going to store the chunks that happen to be where there are things in the world. So if there isn't anything, we don't store a chunk. Like we don't store chunks out here, but where there are things, we store chunks, right? So our chunks can be whatever we want. Let's say they'd be 128 by 128 tiles or something, or 256 by 256 tiles. And that would basically be based on how much sparseness we want to exploit. The bigger the tile size, the less sparseness we can exploit, because you're starting to get into things where you kind of maybe are too big for the thing you're trying to represent. So if a screen is I forget what we said, 17 by 9, is that what we said, 17 by 9? So if a screen is 17 by 9, right? Then if we make something that was like 64 by 64, that might be a good fit for it or something, right? But if we start to get up to too high, we might be losing some sparseness. So it depends on how much we want to do. And if we look at the calc for that, right, if we look at what 256 times 256 is, that's 64K for 1 byte per. And let's say we were storing something a little more aggressive, like maybe we're storing, instead of 1 byte per, maybe we're storing 128 bytes per. That would still be pretty large. That'd be like 8 megabytes for one of these tile chunks, right? And so, like I said, I don't know how big we want those to be exactly, but that's a parameter we can do. So we can start out by doing them 256. That would be 24.8 as our format for our 32-bit integer, where basically the lower 8 bits of the index into the tile map would tell you which of the tiles you were here, and the upper 24 would tell you which of these chunks you were, right? So to be more explicit about that, essentially what we have is a virtual addressing scheme here, right? We've got our Y position of a tile and our X position of a tile, and they're just 32-bit numbers. But instead of acting like 32-bit numbers, we calve the value for X and Y in half, and the lower part, however many bits we decide, if it was 256 by 256, it'd be 8 bits on the lower part. However much that lower part is tells us where in the chunk we are, which tile, which in the 256 by 256 would mean there's 256 tiles across, 256 tiles down in each chunk. Which of those tiles were in a particular chunk, and the upper 24s, so we have an 8-bit, 8-bit, which is a 256 by 256 tile map for each chunk. And then we have a 24,24-bit value that would tell us which of these we're in, and we know that we only store some of these, right? So this would basically be a sparse lookup into our tile universe, right? So that's what we want to do here. For the screen will just remember, for example, it could be whatever its center tile is. We could say the screen is looking at this tile, center tile, and then it's got some offset from that center tile that's looking at. And then what it does is it will ask this guy to please give it whatever the tile maps are that overlap it. So maybe we're looking at a tile boundary here. So this is one tile, this is one chunk, this is one chunk, this is one chunk, this is one chunk. And so creating the screen will basically be about drawing up to 4 of these tile map sections of the tile map chunks, right, to fill in the whole screen. So this might be A, this might be B, C, and D, and up here, right, that would be A, B, C, and D, and this is essentially the screen mapping to that area, right, that region of the tile map sections. So that is what we are trying to accomplish now, is moving to this thing where the screen is just a query into our tile maps, and we get out the tile maps that we wanted, and we draw whatever portion of them happen to overlap the screen, right? And again, it should be immediately obvious how you can now do smooth scrolling if you wanted to with this system. Of course, you could have done it with the other system as well. But this supports smooth scrolling exactly like it supports regular scrolling, because you can query any region and get out what it should be. So if you want to move smoothly along it, you could, or if you want to just do a fixed position like I'm going to do, you can do that as well, right? All right. So in order to do that, what we now need to do is we need to switch to using just one tile X and tile Y. So what I'm going to do is I'm going to go ahead and change our world positions to be that. Now I put an underscore in front of them so I can see everywhere they're used, and that way I can go look at all the code that's using it and fix it. So for recanonicalizing coordinates, we now no longer have to worry about the tile map X and Y, and we also don't have to worry too much about the world count X or the world count Y. What we really need, well, we'll need a different value that we'll talk about in a second, but so we can get rid of those for now. So what we have here is we're just going to, for recanonicalizing coordinates, we're just going to pass those in. And when we recanonicalize the coordinates, we now just have the tile value and the relative value, right? And we still do all the same stuff.
Okay, he's moving good and fast here. I want to make sure I don't miss any steps, because this is going to be a lot of shifting some code around. And then we'll start shifting some bits around. So we don't care about the tile count, and we also don't care about the tile map that we're on, because that whole sort of understanding of how we'll be indexing into the screen window, he called it the window into our game world, that whole understanding changes by packing things like he's intending. And so there we go.
But when we get in here, when we do these adjustments that we were doing for the tile map, we can just get rid of them, right? We no longer have to worry about what tile map we're in, because that's just baked into the value, right? And furthermore, this value is actually now effectively a uint32. I don't know if I'm gonna, it's a little bit tricky, right? Because basically we have an int32 here, and we need to then subtract or add from this value. So I don't know if it makes sense to start calling this a uint32 or not. We're still going to have to deal with the negatives here, so it doesn't really matter. So what we could do is say that the center tile of the world is 0, 0, and things go out to negative 2 billion, positive 2 billion. I don't know if there's any real reason to care one way or the other about that, but I think what I'd rather do is say we never have negative numbers, just to make maybe things a little bit easier in some parts. So I want to say that that's just a uint32, right? And the uint32 then can be subtracted or added from by the offset that we compute, but we want to basically assert that it never goes negative. And so basically what we want to do is, before we do this, we want to assert essentially that whatever we would have been doing to our number, it's not going to be it's not going to cause it to underflow, right? So basically the assertion here is that the tile position that we have is going to be greater than the offset is, and it's a signed unsigned comparison. So basically, like I just want to, how should I do this? What's the easiest way to do this? I want to say like basically the absolute value, right? I want to say that the absolute value of this offset. So I'm just going to say absolute int32, or sorry, absolute int32 to uint32, something like this, where I can basically say whatever.
Oh no. Okay. Absolute int32 to uint32. Well, sure. So one thing that I realized, and I think I mentioned this yesterday, that I would have to do is that I would have to start treating the tiles as strictly 32-bit size integers rather than ints, because ints are going to be treated as 64-bit integers on this machine anyway. So I think all I really need to do, right? Oh, can I just call abs? Like, do I have to call it off of math? I don't. Is it the same thing for floor? No. Okay. So I think all I should need to do then is that. Yeah. Okay. And it'll, well, oh no, we want it to be a U32. Okay, yeah. Okay, so that's right. Not a 32-bit sized signed integer. We want those tiles to be unsigned to get, you know, those bigger access to those bigger numbers. You know, if it's unsigned, then, you know, we have twice as much memory to work with in the positive, and we aren't going to have negative tiles. Makes good sense to me. All right.
Whatever this is, I want to make sure that in the case where it is negative, I want to make sure that this value is always greater than it. So basically, it would be assume that offset is either greater than 0, in which case we can add it. If offset's greater than 0, I almost just want to do this in debug code. So what's our debug code? We have it here. Let's see. It's called Handmade Slow, I believe. Yeah, there we go. So if we're in Handmade Slow, then I'm just going to write this out explicitly, because it was getting too hard to pack into insertion there. So what I want to do is I want to say if the offset is greater than 0.
Okay, this did not go the direction I thought I was going in. So we're just gonna say when, not all caps, when all caps Odin debug, right? And this isn't exactly, I was not sure exactly how to go about mapping this over to my own code base, but he has like these flags that he passes, whether he wants it to be a slow build or not, and whether, you know, it's an internal or a debug build or not. And I just kind of went with Odin debug for everything. And then if there's something I care about that I want to enable, then, and I'm not actually compiling in debug mode, then I can always just do this. That's what I've been doing. It doesn't feel great, but I don't want to have to define more flags to pass in unless it is painfully obvious to me that I should absolutely do that, because it muddies the waters when I can just use compiler switches, and that's what I'd rather do, like built-in compiler switches instead of adding my own flags. So if offset greater than 0, do a thing, otherwise do a different thing, and here we go.
Right, and then if the offset is less than 0, we'll do something else, or if it's 0. What I want to do is say if the offset was less than 0, then I want to basically assert here that the tile is less than the negative offset, right? I'm sorry, greater than the negative offset. So basically, if this value well, it can be greater than or equal to. You could move right to the 0th tile if you wanted to. So basically, if this was like 5 and offset was negative 6, right? I really don't want you to ever do that, because you'll wrap around and go back to the other side of the tile map. Now we could argue. I mean, I guess the other thing I could do is just allow that. I suppose there's no harm in it. We could say that our world's toroidal. I guess now that I think about it, do I?
I forgot about this whole toroidal. I think he's gonna start drawing a bunch of stuff out, but it's like there's toroidal where like you can wrap from one side. I don't know if this is what toroidal means, but the point is there's the idea that you can travel from one end of the world to the other, and then it's kind of like going from the Shire to Mordor, right? You're at the beginning and then you're at the end, versus like wrapping all the way around. You know, like in Skyrim, you can go from Whiterun up to Solitude, but you can't wrap back up. You know, it'd be like, you know, wrapping across the whole entire globe. So yeah, Earth was a donut, always has been. That's right. Now, I think he ultimately goes with the non-wrapping world design, but I think it would be cool to actually be like, oh, I came all the way back across. I think that would actually, but you know, then like, where's the sense of progression? It would be kind of like, this isn't exactly right, but you know, in Morrowind, where the end of the game is in the center of the map and you can always see it. You're always looking at Mordor wherever you are on the outskirts of what is it, Red Mountain. But yeah, it's just interesting to think about how that would actually impact the feel of the flow of the game. It's kind of like going over and starting a new game plus. Like the game playthrough is toroidal, but that's, you know, that's just abstract. That's not geographically how the world actually works. It'd be like you're starting here at the beginning and you're in the Shire, and then like Mordor is over your shoulder, and then you keep going. You go all the way through Middle Earth, and then you come back around and, oh, I'm looking at Mordor. Mordor is in front of me instead of behind it. Anyway.
All right, maybe I'll just say that the world's toroidal, and then we don't care. If you walk off one end of the world, you walk back on the other side. I mean, we're saying you can't get to the end of the world anyway, so I guess I could just say that that was true. So I could just say, world is assumed to be toroidal.
Yeah, if I remember right, he walks this back and decides not to do it this way. But we'll just stick with the direction he's going in for now. And I can't remember at all why it goes back the other way, and we don't allow wrapping. I think we start running into random bugs with the way the math works out or something like that, and that's what makes him walk that back.
If you step off one end, you come back on the other, I guess. Let's just say that's true, and then that's it. And so what, for those of you who don't know what I mean when I say toroidal, basically there's a concept called topology, a branch of mathematics and so on, which honestly
yeah, that's a perfect example. Way simpler than any of the stupid shit I was trying to say. Pac-Man is toroidal. You go out from one end, and then you just wrap back out on the other side of the, you know, the Pac-Man maze.
I'm not an expert in, so if you want to know more about it, you really got to find some better sources. But basically, there's these sort of concepts of how things are connected, how spaces are connected. And so what I was thinking about originally would be called disk topology, which is basically to say that essentially my world was sort of, they call it homeomorphic usually, was basically, or isomorphic, to a disk. So basically what that means is wherever I could go, right? I've got a guy, and he's walking around on the surface of this world that I've created. Wherever he would walk, right, the rules are the same as if I was just on some kind of a flat disk, right? There's no difference between these two. I could warp this one into this one, and the connectivity is the same. Another way of thinking about it is if I had a tail, if I had a tail that was pinned to the center, right, and I started walking around, the tail would loop around the exact same way on a disk as it would on me. There's no sort of fanciness that you could play. But toroidal topology means that my world is actually homeomorphic to a torus. Now I know that sounds a little weird, but basically if you've ever seen a torus before, this is going to be kind of a trick to draw, but it's basically a donut, right? It's basically a thing that looks kind of like this sort of a thing, right, where it's got a hole in it, and sort of it's got rings around it, right? Like this sort of thing, you know what I'm saying? And so you kind of go along the, right? Like a life preserver, that sort of thing, right? So if the world is homeomorphic to a torus, if you think about what a torus looks like, it means that in either axis, you can walk along and just keep walking. You can just loop and loop and loop, which means if I walk off one end, I walk back onto the other, right? And if you think about this torus, you could cut it. You could cut it along the seam, and then cut it along this seam. I could pick two seams and cut it and unwrap it into my world, right? This right here is this seam, right? And this right here is this seam. And you can see how I could bend that back into my torus, and the rules here are the same as on the torus. If I walk along it, right, and I can walk like this pattern on it, the same is true on the torus, right? It loops around the torus as it goes around.
Man, I'm racking my brain to try and think of like a contemporary open world 3D game that does something like that. Like it's not Skyrim, not that that's super contemporary anymore, but that kind of like sets a benchmark for open world. And then like what you think about like GTA, you're just on a big island, right? GTA 5. And basically that's the way it works for all the other GTA games, right? You're in a big city and you can go from one end to the other, but you can't wrap all the way back around the other side of Vice City, right? Like unless you get on like a, you already get on like a, yeah, that's not the way the map works. Elden Ring is obviously a more recent example, but I'm thinking like you start off in like the bottom left corner of the map, right? And then you go to the far ends of the top right. Imagine, you know, setting that tone, that expectation, like you're going to go to the ends of the earth for the player. You're going to fight your way through all this nasty stuff. You're going to get to that upper right corner of the map. And what's waiting for you on the other side? It's kind of like, actually, there is a game that did this. It was, wasn't it No Man's Sky? You got to the center of the universe, and then there was just another identical, you know, not identical universe waiting for you on the other side. But it wasn't that just so disappointing? I remember that particular thing waiting for you at the end of No Man's Sky being met with a lot of criticism. Like, what? It just keeps, I have to do this again, and it's the same, but it's a different universe. You could just go backwards from the starting point to reach the end of the game. Yeah, but for some reason, let's just suppose there's nothing there. You know, like if you're starting off in the bottom left corner, and then there's like a big wall or there's a big mountain, you know, and there's some kind of door or whatever that's blocked, and you just come out of that door once you get to the other side of the game world, right? And then you're just like, whoa, I started where I finished the whole time, but then, you know, you get that almost sense of anticlimactic accomplishment where it's like, wow, I just did all this to wind up where I started. Depending on how you handle that. If you handle it a little bit differently from how No Man's Sky handled it. Like supposedly, and I've never even played No Man's Sky, so I can't vouch for this, but evidently they added a bunch of stuff to that game over the years, right? And they made the replayability actually really good. So, you know, you just have to wait for about 5 to 10 years after you've launched your game, and then it'll be satisfying, I guess, is the lesson there.
Right. And so when I say toroidal topology, what that means is that I've got a world that's actually a torus now, even though it's not shaped like that in terms of its physical form. It's behaving as if it were on the surface of a torus, not on the surface of a plate or a disk, right? And so this is toroidal topology. That's what that is. Yeah. If you're into topology and want to read more about it, I don't know what to recommend. Maybe Everyone Has a Tail. Let me see. Everyone Has a Tail. Kuga. So let's see. That's what it's called. Galwa's Dream. That's what it's called. Most books on topology are very hard to read. This one is not perfect, but it would probably be the best one to start with. I don't know, maybe. Topology is hard to kind of get into, but Galois Dream is pretty good, and maybe people on the forums could recommend some other things as well. But that's something, you know, if you're into topologies, there's a lot of other things. Yeah.
Yeah, Devil, it's you could totally do that where it's just and we'll actually get to a point in the series, I'm pretty sure, where we're just staring down a bottomless staircase, essentially working on the kind of 3D traversal up and down different rooms, up and down staircases, and then that would be the way it would work. You would get down to that bottommost staircase, and then you would just drop down back at the very topmost level again. Sorry, I just bumped the mic, but yeah, that's exactly how that would go. And then you'd be like, oh, what the hell? I can't get back up there. Unless you got, like, double jump or something. Then you'd have to, you know, either reload a save, but what if you don't have saves? You're screwed. You got to go all the way through, you know, all 4 billion of those rooms again, or whatever, to get back to where you fell through at the end of the game world.
To think about. Anyway, so I'm going to go ahead and say that, and that way we don't even have that problem there. We can just go ahead and wrap. We don't have to assert. If you walk off one end, you walk on the other. Everyone's happy. No real problems. I think this will do the addition properly with the signed addition, but we'll have to check to make sure that's true, although it shouldn't be too hard to verify that that's working. We then don't have to check that at all. It's an unsigned integer. We don't have to care. Oh, wait, that's the tile relative thing. So we don't have to check that at all. Are we not checking to see whether tile relative is greater than or equal to 0? I don't know. I must have deleted that by accident. So we'll put that back in, and we'll save that. All right. So there we go.
Didn't he literally just do that? He deleted this check, and then he re-added it? Yeah. Oh, no, wait. Right? I don't understand what... Maybe that was a typo. That must have been a typo on his end. I think he always meant for it to be the relative tile that he was checking the bounds on. I'm not sure what's going on with this here, because he turns this into an int. So maybe when he goes to plus equal it on the tile that we're on in the world, it just implicitly converts that int into a U32. But I suppose this just needs to be cast here. I was casting it up here, but I'm worried that doing anything slightly different from him is just going to screw me over in some weird bitty way that I can't foresee right now. So I'm just going to go with this for now.
Everyone's happy, no real problems. I think this will do the addition properly with the signed addition, but we'll have to check to make sure that's true, although it shouldn't be too hard to verify that. Oh, wait, that's the tile relative thing. So we don't have to check that at all. Are we not checking to see whether tile relative is greater than or equal to 0? I don't know. I must have deleted that by accident. So we'll put that back in, and we'll save that. All right. So there we go.
And he also has a to-do right here about fixing the floating point math, but because we're using Odin's built-in floor proc on the math package, I think the math is just probably better, more reliable, and that's why we never trip this assert where the tile relative actually turns out to be equal to the size of a tile side. So I think, and that was basically what I was guessing at yesterday, but I'm pretty sure that's the case at this point.
We also need, so that's all we really need to do for that, because it's just, that's a standard adjustment. Tile X is not a member of world position, right? So that's fine, because I just changed what it was meaning there. Okay. So let's move on to here. Is world point empty? I passed the canonical position. We no longer have to do this get tile map thing exactly this way. Really what we would do here, so is world point empty, what we want to do is I guess we could still call get tile map, and we just call tile X and tile Y, and that will get us back the tile map for that tile location. And then when we do is tile map point empty, we would pass the tile map, and we'd pass those. Okay, so if you look at what has to happen here, this is basically going to be our query into the tile system to get the chunk that we're on, and then we're going to have to query inside the chunk. And so what we want to do is we want to have basically a mapped result. So we have these world positions that we're going to use, and then we're going to kind of introduce a lower level thing, and this will never, I think, be exposed. Well, yeah, it might be. Basically, what we're going to have to do is have our tile chunk position, right? Which is actually going to be something that's a little more explicit. And this would basically be like sort of a tile map. This would have our tile map X and our tile map Y in it, which are essentially chunks. So I'm going to maybe start to call them not maps anymore, because tile map kind of sounds like something that you authored, and that's not the case. And then the tile X and the tile Y inside that chunk, right? So we're basically moving that stuff that we have in here into a transient variable, a transient struct, which is only used during the accessing, right? And so what we would do is we'd essentially have a simple function that's going to be trivial to implement. It's just like a shift and an add, and kind of a thing, where we do, where we do kind of a get chunk position for a canonical, right? We get that back. We have our chunk pose, right? And then we just say we can get the tile map for a chunk pose, and
slow down there, Casey. Oh, these are all U32s. Okay, so I guess we just need to have something like this around, like he said, to store as a result. Sounds like. Yeah, and then he pulls it out of getting the position for the world position. Makes sense. Is world. So we get our tile chunk out of get tile. Oh, it's going to be chunk position. Get chunk position 4. I don't know. I think I'm just going to do something a little dangerous. I'm going to do something slightly different. He calls this the chunk position. That's fine. And we pass in that canonical position. I just want to change all of these to say world pose, but maybe he does that anyway.
This will basically be a tile chunk now. We can get back a tile chunk, and then we can also ask for, on a particular one, whether the chunk pose is empty or not, right? So we can say, for the tile map that we got back, does this tile X and tile Y? And so this is inside the tile. Now these are going to be named the same thing. So this is a rel tile X, I guess, and this is kind of, we've got chunk relative X and chunk relative Y. So it's kind of hard with these sorts of things. But like I said, this is going to be kind of buried, so that's okay. Nobody in the interface now has to think about those anymore. So if they can kind of think about absolute tile X, absolute tile Y. And we could call these abs tile X, abs tile Y if we wanted to. In fact, maybe that's a good thing.
Oh dear. Cleaning it up in one way, but then we have, you know, that chunk position struct. It's muddying things up a bit for me, but I'm hoping it'll become clear here. I don't really... See, before he was calling these relative tile coordinates tile relative. And then over here, he starts calling them relative tile. Which is it? I just want my convention, and I want that convention to be stuck to. Whatever it is. And I certainly don't like calling it the chunk rel. Maybe I'm being too much. Maybe he changes that and rips that out in a second here anyway.
And then we can have rel tile X, rel tile Y.
Yeah. Okay, that's what he does. So, whatever. Just stick with this. Don't overcomplicate it.
And then these right here could be, maybe I might change these to be calling these offsets as well, like offset X, offset Y. We'll have to think about that. Okay. So again, we're just moving down the stuff that we had here. We're moving it down into another layer that kind of will always do it, so we don't have to track those. We're just, everyone who actually uses positions will only know about their absolute tile X and Y, and then we'll only compute those relative ones on the fly, and the computation will set up to be basically free, so that it just really doesn't cost anything to actually do it. So we'll have this get chunk pose, right, and our internal get chunk pose here. Again, this will probably, this one actually definitely I think we'd want to make it inline because it'll be so easy. This will be a tile chunk position. Sorry, this will be a world position that it passes in, right? That world position, excuse me. Basically, we're going to use the abs tile X and the abs tile Y. And in fact, you know what? We could just do, we don't really need the rel X and the rel Y here, so this could just take the X and the Y so that even people who aren't using anything in particular can look it up generically. We could basically say, okay, get the chunk position for these two things, right? So there's abs tile X, chunk pose, abs tile Y, right? So basically, these two come in, and all we need to do now...
Make sure I update that before I forget. Okay.
Now is make a tile chunk position, and that tile chunk position is going to have which tile chunk X and Y you're in, and where you are relative to that one, right? Rel tile X, rel tile Y, right? And then I said before, basically, that what we want to do is we want to basically define our tile map. I should probably pass the world here so that we can have worlds of dynamic sizes. We may want to fix this so that the map can be computed at compile time, but for now we'll do it in dynamically. Right. What I want to say here is basically that the tile chunk X is going to use the abs tile X. Shifted down by however many whatever the fractional bit count is, right? So there's going to be essentially a chunk shift value, right? So abs tile X gets shifted down by that, abs tile Y also. And so all that's doing, right, remember I said I want to store it something like this. So there's going to be fractional bits. This is a 32-bit value here, right? There's going to be fractional bits. Maybe there's 8 of them. Maybe so 2 bits by 2 bits chunks. I don't know. We'll start with that. And 24 bits here. All I want to do for the chunk index is just, I'm shifting that down. So I'm getting rid of this. I'm shifting down the 24. So we just have the 24. So we're basically looking at our new value is going to be 24 bits and 8 zeros at the top and 24 bits of actual value here.
Put some comments denoting where your dangerous boy tendencies took place to help future debugging. Yeah, I mean, I'm not going to get too bold with that. Once we get to a point where I'm not really trying to keep things in line with how he's doing them, I can just experiment and do whatever. I'll probably just keep a bunch of different branches to have different, ideas to chase down inside of. And that way I've got like one source of truth that is not straying too far from how he does things. And then I have all these other branches where I can, I could basically duplicate my game package, right? And then go hog wild with it. If I make a disaster of it, that's fine because I have, this other package that's just fine the way it is. And I can always refer to it if I'm like, well, how did we do this? How did that work? And, or I can study some part of it to really get a better understanding of it if I want to try and go implement something similar myself. But I want it to be, towards a more specific mechanic or type of game. And so I just need to make a tweak, but I don't know exactly what way I want to make it in, that sort of thing. But it looks like, yeah, so this is how he's doing it. He's going to store a chunk shift value on the game world to get out the indices of the chunk that we're on in the game world. And then he's going to do the same thing for the tile X and Y. And I'm guessing he'll call it like tile shift or something like that. And I actually I was trying to make some changes to the code and I missed what he was doing with this diagram here.
And so all that's doing, right, remember I said I want to store it something like this. So there's going to be fractional bits. This is a 32-bit value here, right? There's going to be fractional bits. Maybe there's 8 of them. Maybe so 2 bits by 2 bits chunks. I don't know. We'll start with that. And 24 bits here. All I want to do for the chunk index is just, I'm shifting that down. So I'm getting rid of this. I'm shifting down the 24. So we just have the 24. So we're basically looking at our new value is going to be 24 bits and 8 zeros at the top and 24 bits of actual value here, right? So we do those 2 shifts down.
Yeah, so he was just covering what exactly is the point of doing these shifts here. So let me go ahead and tab back over. The same thing, right? We take in what we passed and we shift it to get the world coordinate, essentially the world chunk coordinate, both as far as the X and Y go. And then, I mean, same thing is going to happen here, I suppose. He's just going to shift out a different amount.
We might do something different here in the long run and just compute like a hash value directly for how to look up the tile map, but that's going to be down when we actually start implementing the engine. All right, so we got rel tile X and rel tile Y. Those are now going to be the exact same thing in reverse. We're going to and with a chunk mask, right?
Oh, okay. Instead of shifting, we're in a bitwise and right on the mask. Okay. I had that wrong, but I understood where he was going with that. Aha! I remember doing this the first time and being like, I don't know what the hell is going on. I want to get, here's what I care about. I want to get to a point with this game where I can just start making particle effects for fire, and then I want to throw fireballs. There's a much easier way of doing this. I'm sure I could boot up Unreal Engine and then start doing some kind of particle effects class modifications and have some fire that way. But I want to make that fire myself. I want to go discover fire all on my own without the help of, tens of thousands or hundreds of thousands of lines of code in Unreal Engine or Unity or whatever it is. Yes, that is a good call out. We don't want to just modify the X tile on both of those. And I don't understand. I did something wrong here. Oh, I don't know why I keep doing this. I keep trying to define my procedures that way, and that's bad. Bad. I'm guessing this is just a pointer to the game world. We're pretty wide here. Do I want to just do that. Does that even... Does that work? Let's just do this. The way I have been doing this is just breaking up the lines that the parameters are on. And yeah, so we don't have these chunk shift or chunk mask members here. So we'll see. I'm guessing they're just going to be U32s again.
Like this. And the chunk mask is just the thing that will mask it out. Now, if the shift down is 8, then if you think about it, if we actually wanted to, we could probably do something that compute. Well, we're just going to store the mask. There's no point in getting things fancier. All right.
Oh, I didn't realize that was you, Mr. Intrinsic. That's what I've decided to call you, because your username looks like it should be an intrinsic. Already the float stuff earlier. Math.floor returns a float. Yeah, of course. Why else explicitly cast it to int? Right. Floats are tricky, though, if you're unlucky the way that expands, e.g. casting the int result of math.floor 5.5 to... Okay. That is like casting... I'm not sure I follow what you mean by... Can you guys see my... mouse here? I think you can probably just see it. I'm not sure what this means. Like, are you just talking about the how these evaluate to the same thing? I see. So yeah, right. The opposite. Yeah, no. These all mean the same thing. Okay, I think I see what you're saying. So if we cast the floor result. The call to the floor proc on 5.5, casting the results of that. Well, how can that be? That should just give you 5 if you cast. Because the result of math.floor with the input of 5.5 should just give you 5 even. Versus casting 4.99999 to 4. Usually if you want int floor some positive float, you just cast to int, which will do truncation, i.e. round towards 0, which is the same as round towards negative infinity, i.e. floor, as long as some positive float is indeed positive. I see. I think. So you're saying the fact that we get a float out of that floor result and then we try to cast it to an int is doing the truncation. Can 5 be exactly represented by floats, though? Well, I guess I'm just making an assumption that when we call math.floor on 5.5, we're going to get 5.0, and that, I mean, 5.000, or not 000, but 00000, right, out towards infinity, or at least to the extent that a float can represent 5. That's as close as we can exactly represent, you know, the integer 5 in float, is it not? If you want to cast the result of floor on some positive float, just cast to int. Meaning don't floor it, right? Just do the cast on the float directly, is what you're saying? I think I suppose that if I go over here to my floor call, I'm trusting that this is going to do what I want. And it's going to floor it towards negative infinity. So that, because we don't care, I think regardless, if it's positive, regardless, it's going to do the same thing, because it's going to either it's going to floor and then truncate towards 0, or it's going to just floor towards 0. Like, whether it's doing a truncation towards 0 or not, we're getting closer to 0, which is what we want. And then if we're in the negatives, it was my understanding that, math.floor, let's just say, for sake of argument, or for the sake of trying to get on the same page here, because I know I'm like reading out what you're typing, and I'm also trying to articulate how my brain is thinking about this, but I'm doing a terrible job. Let's say we have two different negative floats. Like, I think I can appreciate what you're driving at, and that this cast, right, of this floor call on a positive float is going to truncate the thing towards 0, right? But what we care about is the case where it's negative, I think. I think that's the part that we're concerned about, because that was the part that Casey was talking about in an earlier day. So if we have math.floor on these, and we are, every single case where this gets called, we are going to cast it to an int. The result of this should be -3. The result of this should be -3. Right? And then, well, the result of this before the cast should be -3. And then when we cast to an integer, right, this part out here, that should bring us out to, just a signed integer of -3. That's like the steps that's happening. We're taking -2.2, whether it's -2.2 or -2.8, right? Whereas if we were calling math.truncate, right, on the -2.2 or the -2.8, I guess we don't need both of these examples. This was my understanding of what would happen, right? This would actually become -2, and we'd be truncating towards 0 if I called math.truncate. Like, I'm trusting that this floor is giving me, a float that I can then reliably cast over to an integer that is like rounding towards, not rounding, but flooring towards -infinity, right? You want to get closer to 0 by less than 1. The thing above, and jump you almost to. The representable float that is closest to 5 might be less than 5. There's no reason that 1 greater than 5 would be more likely. Truncation is truncation. So if it's less than 5, it will be truncated to 4. I think I understand what it is you're concerned about here, which is that, we may be calling floor here, right? But this cast, getting out of a float and into an integer, particularly if it's positive, like I'm just going to use your example here, because we had 5.5, or in fact, I don't want to uncomment those out and then have the language server scream at me. 4.9999. These are the examples you were using, right? So when you write stuff like -3.0, it's highly misleading. -3 is not exactly representable by floats. Okay, I can appreciate that. To make the thought experiment useful, try with -2.999. Interesting. And -3.0001. Not as interesting. Okay. Yeah, I think I don't want to get too sidetracked on this because we still have a ways to go in the code here, but certainly I want to make sure I have a pretty good understanding of this myself for a case where I don't think for a case where this would matter more, I guess. But basically, let me see here. Let me look at this example you had. So you're saying that both of these could evaluate to 4 after the cast. Is that right? Oops. Right. And right, okay. Yeah, so how would we do this then? Right? That's the thing. Because I'm looking at, I think I just kind of, where is that? Yeah. Right, so that's why he adds the 0.5. But I suppose this, I'm entrusting that this is going to do that for me. Like we go to floor, we're dealing with F32, so let's just go over here. Like I'm putting faith in the notion that flooring this is going to give me what I want to expect. Because he's writing his own, I mean, he is calling floor from math.h, I think, underneath the hood. And I'm talking specifically about this up here, if you can see my mouse. When he does this, like inside of this function that he's written, I'm pretty sure he's just calling floor. But if that implementation does the same thing as what Odin's does, which I can't, just looking at it at a glance here, I can't tell if this is actually circumventing the concern that you're expressing here. Because I would have expected to see something that looks kind of like Casey's code. Maybe maybe this is doing that, right? What gets you to the 4.99999 is the math.floor operation. Let me backtrack here. Oh, okay. Yeah, I got you. So you're saying okay. Yeah, so this example is just pointless. And then this goes to this or this. I'm sorry if I seem completely stupid in trying to go about understanding this, but I really want to make sure that I do. What I wrote is correct, but it misses the interesting bug. Yeah. Yeah, and I guess the thing that I'm wondering is there even a bug to be seen here? Because if there was, I would have expected to be tripping the assert that Casey is, where he's rounding back up towards 60 when he finally calculates the relative tile that he's on. And so he has to change this assert, right? To be worried about the because he doesn't want to trip it, because this keeps on evaluating out to 60 depending on where his player is at. you would write 5.0001. So really, this is just the thing to keep in mind, is that whether I'm passing in this value or this value, even though they're on either side of, you know, the notion of where 5 is, they'll cast down to 4 in either case. Yeah. And I guess that's why... Actually, I don't know when Casey did his little implementation. I'm going to have to spend some more time looking into this and thinking about this off stream, because I want to get this day of coding wrapped up. They will cast down to different things. That's the bug. Right. Right, that is... But the point is that the fact that they cast down to different things means that our offset is wrong, right? So that when we go... Like, that's where the bug originates, but it's the fact that we're using it to calculate an inappropriate tile value here, right? Or tile relative value, I should say. It gets us the bug that we observe as a result of assuming that this is doing what I thought it was doing means that we're getting incorrect coordinates into our game world. So, yeah, I'll sit with that some more, but I appreciate the input because that's an important... Like, I guess my intuition would never have led me to... like, unless I tested it out and started throwing in random stuff here, I would never suppose that, you know, casting this, either of these values would give me 4. I would be pretty grumpy looking at that, the result of that, and getting a 4 out. And I would assume that I was doing something very wrong, but no, that's just a result that you should expect to happen once you do that cast, I think is the takeaway here. Even though it's not what you intend. Like, you intend to get this back, right? Much in the same way you would intend this cast to give you 4. I think that much I have correct. But anyway, so I'll actually put in a to-do here for myself. Sit with the ramifications of casting, of not getting what you expect, casting floats to ints. Is that the proper way to think about that? And then just leave that in. Sit with this and think about, like, what would you do to circumvent this, right? I guess you would want to make sure that the result you get out of casting, you know, 5.00001, you want to make sure that the result you get out of that is what you want logically to have happen, which is a 5. You do nothing, you just cast. Hold on. Let me ban this person. This person, it's a bot. The first one casts to 5. Oh, it does. I thought you were saying the opposite, man. Hold on. Right. Well, because this right here, this is not the same as casting this. Like, should I make that more explicit? You can just add the 0.9 before the typecast. Devil says you can add the 9/10 of a decimal before the typecast, and then Mr. Intrinsic says, no, do nothing, just cast. But then the 4.999 would cast down to 4, so why not add that so it casts to 5? The point is we don't know what case math.floor lands us in, and that's why we don't want the math.floor. Just do the cast. I see. I don't know how to reconcile that with the fact that that's what, well, okay. I think I finally see now. Because when Casey writes this function, right, I think he is casting floor. Or maybe he wasn't. I'd have to go and look at the source. But he may have just been casting it, or he may have been fooling around with the floor function, or maybe his understanding was just incorrect in that instance. Well, yeah, I don't want to belabor the point. But yeah, by do nothing, I mean don't do the math.floor. Meaning that this is all we have to do. Whoops. Tab back over here. And the math.floor does not give us the result we're expecting. Whereas casting it will truncate it towards 0 from where it sits. Okay. But if I do this, so what if I'm doing this and it's negative though? Right? Because we've been talking about the positive case this whole time. So if we had negative, we want that to be to become a 6. And I thought that was why we were calling math.floor to begin with. Right? I would guess you just cast. You can handle negative inputs by checking for them, doing absolute, doing the cast. Okay. Yeah, now that you mention it, I think that is what he does. So, I'm just going to back this off. And I will look at making that change, right, where we do the abs on the value if it's negative, because I think he does have a conditional in that, floor real 32 to in 32 function that he wrote. I think, if I remember right, that is what he did. It's just weird, right? Because, when you call floor, you want the conceptual understanding of floor to negative infinity to happen. Negative turns the float class of the value whether normal infinity or negative infinity. Was there another? I guess what I'm looking for is a built-in way to do that, but I'm not seeing it at a glance here. So handling negatives also includes subtracting 1. Right. So, okay. Because then you would be truncating towards 0 after you've done the subtract, which would get you the result that you want conceptually, which is to go towards negative infinity. That's the trippy thing about floats. If you want to store integers, use integers and not floats. Yeah, for sure. I mean, that sort of thing has tripped up my coworkers in particular that have to deal with floating point values, whereas I'm just giving them the data. That's generally the nature of my job. So I don't actually have to think too hard about data types on a given workday ever, other than like, is there, can I take this table out of whatever it is, Postgres, and can I store it in SQL Server if I have to make some changes? But it's a good point to remember that you can't just go back and forth between floats and ints and pretend it's all gonna be peachy in the end. And this is why JavaScript not having ints, only floats, is so crap. Well, add it to the list, man. Okay, so let's move on. I think I get it. I'll change this to say, do this floor in the way that it should be done. Not in the manner we think it's already being done. Right, so just fix this so that it's doing like what you said. If we want to go towards negative infinity and we're in the negatives already, subtract 1, truncate towards 0. There you go. But get rid of math.floor. I think is the main takeaway. Okay. Cool. Appreciate it. Good. And yeah, I'll have to, because when Casey was implementing it, I wasn't paying much attention because I was just, happily assuming that math.floor would get me to where I needed to go. And evidently that was wrong. And so now maybe once I do the work of making this calculate the offset correctly, I'll trip that assertion because we'll get back towards 60. But his to-do says literally this, to fix floating point math so that this assert can be less than, not less than or equal to. So, I don't know. All right, enough is enough. Moving on.
And so basically the chunk mask is going to be all 1s down here and all 0s up here, so that we end with it, we get rid of that 24 part. We get rid of it's gone. So we're just left with an 8-bit value.
Subtract 1 is an integer operation, so I'll do it after the cast. Good point. Okay, I'll just, one last to do here. Note, subtract 1 after the cast if negative. But otherwise, we don't need to do that. Yeah, well, that makes perfect sense, right? Because we truncate towards 0. We want to go towards negative infinity. So truncate, go ahead and get the integer out, but then subtract 1. Okay, I can follow that. I'm very sure that I just said that correctly, and I'm thinking about it correctly.
That would say what the relative tile x is, right? And that's it. That's the entirety of what we need to do there. So in the world, we now have these two values, right? We have a chunk shift, and we have a chunk mask, and those two I'm going to set.
I didn't catch what he just changed there.
That 24 part, we get rid of it's gone. So we're just left with an 8-bit value, that would say what the relative tile x is, right? And that's it. That's the entirety of what we need to do there.
I didn't miss
anything.
In the
world, we now have these two values, right? We have a chunk shift, and we have a chunk mask, and those two I'm going to set them at the moment to basically be the two values that I said before. I'm going to say that we have a chunk shift and a chunk mask. The chunk mask is going to be, I'm just going to assume that it's that I said before,
And you know what? That's probably what that to-do is that he marked for himself, is to like properly do that subtraction after the cast. I like, obviously it's been months and months since I saw him make that change to fix that floating point stuff, but I'm almost certain that's what he winds up doing in the end.
Basically be the two values that I said before. I'm going to say that we have a chunk shift and a chunk mask. The chunk mask is going to be, I'm just going to assume that it's 8 bits for now. So we shift down by 8 and we mask out by FF. So that we basically are using 24 dot, note, Casey, this is set to using 256 by 256 tile chunks, right? So there we go. So that's that. Excuse me. And then we have to go ahead and say, and actually use this. So we do the get chunk 4, get tile map. That'll have to now take those, and is tile map point empty? I think, for the most part, this stuff just works. I think these will just work the same as they used to. Count X and count Y will now be set to 256 by 256, and furthermore, they will basically be they'll be only one. So there'll be a world, basically a chunk dim, we'll call it, let's say, where a chunk dim will...
Yeah, so now instead of like having our tile map or tile chunk representations in the world, I'm just gonna see what happens if I just get rid of these constants. Well, maybe it should be like chunk dim, just because I like to have those defined as constants, those sorts of things. And then over here, I don't know what he calls that, is he gonna make that a U32? That's just over here defined as an int, but I guess it doesn't really matter too much. It's like that. and then these will be no more. In fact, you can just kind of comment those out and see what comes of it.
Basically be 256 across. So now we'll just...
So yeah, did I even finish my sentence earlier? We're taking that rectangular, you know, understanding of what a tile map is and turning it into just like a square chunk that we pull out of the world as needed.
Switch to using chunk dim instead of count x, count y, so chunk dim, that. And off we go. Wow, only 15 minutes left in the stream.
Only. That feels like a long time. Yeah, so count x. Where else is that coming up? So over here. Over here. And over here. And I guess we're going to have an issue with comparing those. So maybe those should just wind up being ints. Did he actually add that to the world? Not yet.
Haven't got the neck worked out today yet. All right. Chunk dim is not. That's right. That's true. Chunk dim. There we go. So we got all those. And let's see. So test tile x.
Well, I guess he gets those implicit casts, so I'm going to have to be explicit about it because Odin's going to make me do it that way. Pretty sure that's going to want an int. All of these, yeah, are ints. Well, maybe not. These might be in 32s here. And I missed a comma. Where did I miss that comma? My trailing commas, no! I look like a fool again.
Test tile y. We could, those are never allowed to be negative, so we could just make them always be positive, which I think is probably what we want to do in here as well. So we'll just say that these always have to be there. We don't have to check against that. In fact, these are always going to do lookups into the chunk map, and all tiles are valid, so we don't even need this check anymore. We can just say that all of these are unchecked, basically, because there really isn't any way to do them otherwise. So basically, yeah, basically all we need to do is check to see if the tile map is valid. If the tile map is valid, basically everything should work from there on. It's only assertions, because there's never going to be a way to look up something else. So wait, where's my empty tile map value? Is that? Okay. So get tile value unchecked. That's going to pass the tile map, tile test x, tile test y, like that, and that will be...
Yeah, so now I don't have to actually do this cast over here, but these are going to have to be changed, right? Which means I don't have to do that cast there either. I should have just waited. But does indexing... Oh, that's great. Okay, Odin will actually implicitly cast the indexing into the slice versus... in Zig, I'm pretty sure I would have had to be like, you know, U32 here. Or not U32, but int. But it would have looked like, you know, that. And I'm like very certain that I had plenty of places in my Zig code base where I was having to do this just to index into my it wasn't a slice, but my multi-pointer. Very happy to not have to do that here.
Basically do a check here. These are all uints, so they don't have to check against 0, but they do have to check these. Let's go ahead and leave those assertions in there to make sure that we're never outside the chunk dim, right? So they have to...
Right. Okay, yeah, so I changed that somewhat. And then, like you said, we don't need to check whether it's negative or not.
Be below that, and then we will just go ahead and do. Oops, I typed count dim, which is not right. Chunk dim, and that is that. I think, right? Let's take a look here.
Well, I mean, he's just working through compiler errors here, so I might as well. Oh no. What is that? That looks like Oh, because we've defined... All right. Well, maybe I should let him do his thing. And it looks like those are the only errors anyway, right? Yeah, so... Well, there's probably other issues, but we can't get past the fact that these tile maps now do not correspond to our tile chunk dimensions.
Tile relic, these should be abs tile, and chunk position 4. Function needs to take the world, certainly. Get tile map, tile chunk. Of course, we now have tile chunk, which is exactly the same as our tiles from before. And then we still have our tile maps array, and then we need to do our sparseness. That to do.
Was this a reference? Oh, he passes in, okay. Abs, tile, X. Passes in the members of those. And then, what's going on with this? Does this want U32s now too? Maybe he leaves it alone. This seems like it's going to be wrong. Yeah, this has to be different. It's going to be, well... Yeah, we're not getting a tile map out. We're getting a tile chunk. But I think... Whoops. This check is just going to look different. A good deal different when we're done with it.
Chunk, which is exactly the same as our tiles from before. And
he actually renames tile map altogether to tile chunk. So let's go find that. And we'll just actually do a sweep here for tile chunk. Good. Good.
And then we still have our tile maps array, and then we need to do our sparseness. That to do is still valid. We get rid of these. We've got these here to do our sparse.
Did I already do that? I think I did on the, well, I commented them out, but we can just chop those out now.
Sparseness, that to do is still valid. We get rid of these. We've got these here. There we go. These are gonna, this is gonna go away. In fact, it already could, I think. This is gonna be something that we can just put in here. So lower left X, that could just be here.
Okay, so he just takes those off of the world, right? And makes them local here. So anywhere I am using that, I need to get the call off the world removed. And now we are still a bit too wide. Lower, okay, we're fine.
Okay, and where are we at? Tile chunk, and this is really get tile chunk now. So these are actually, map is really chunk in all of these places.
Yeah, that's a lot of tile map references, but they can't all hang around. I guess... Yeah, we shouldn't need to assert, or we shouldn't need to guard against whether they're greater than or equal to 0. But this should probably just be, like, what we'd be comparing here is making sure that we're within the bounds of the number of chunks that we can have in X or Y. The answer to what that needs to look like is not obvious to me, but anyway. Tile map, tile chunk, and I guess those parameters should change too. And this is complaining because these are ints, but I don't think they're going to hang around. Let's just see what happens.
Yeah, there we go. And so these, for now, we're also basically saying that these lookups, yeah, this is kind of a meaningless check as well. But we'll kind of get one thing at a time. We've got to actually sort of get things into roughly workable shape before we talk about how we're actually, because right now I haven't talked about how we're actually going to do the sparse lookup. And in some sense, we don't even want to do the sparse lookup yet. That's an engine thing. So we want to do is spec it all to work properly and then move it off into a file that will basically say, when we start doing the engine, this is one thing we have to do, right? But we don't need to worry about about that yet, because we can just do a dense lookup for our testing purposes and not have to worry about it. Okay, so tile chunk. There we go. Tile chunk value. And let's see. Yeah, there we go. So those chunks, same here. Let's just do map to chunk.
Probably gonna have to sweep all of the variable references to a tile map over to a chunk. Yeah, like, I mean, right here. I missed that when I was doing that change over here. Man, oh man. Yeah, so I guess he's keeping this here. Maybe he's going to leave that check in place. Yeah, he's leaving these as int32s, but I'm pretty sure that's only working out because C is turning the U32s into int32s implicitly for him. Right? Yeah, so let's just go ahead and throw caution to the wind. Yeah, I mean, I guess we do want to change the player tile chunk as well, don't we? Change it from player tile map X to player tile chunk X, right?
There we go. And we don't really want that. It shouldn't be is tile chunk point empty. It's just is tile empty, right? How did we do? Where do we call that from? Is world point empty? So this is just is tile empty. And I guess this one is, yeah, is tile chunk point empty. I guess that's actually true. So is tile chunk tile empty is probably the correct thing, because it's not.
Is tile chunk tile? Do we go for it? Do we give it that? God, where is it? It's is tile chunk point. I feel like I want it to still be chunk point. Oh, I guess we literally are. There's just something about the redundancy here. I feel like, for the sake of brevity, I could do this. Is tile empty? Like, is this tile in the entire world, out of the whole game world? Because we know we're going to ask about a specific chunk, because we're passing it in, right? We'll see if this, changing this name, causes me headaches or not.
Not testing a point anymore. It's just testing a tile to see if it's empty. It doesn't even get point information. All right. Get chunk position 4, can pose abs tile X, can pose abs tile Y. There we go. And let's see, the chunk pose tile X and tile Y.
So over here, oh, okay, so those aren't going to be turned into U32s because, well, I thought all of those were U32s. What? Wait a minute. Is this taking me to the wrong? Oh, okay. These are rel tile X and Y. I believe that's what it was complaining about. I was trying to get at something that doesn't exist. And then instead of this being point, we're just going to say is tile empty. So actually, is this abs tile or is this relative tile?
Or is it, what is it called? It's like tile relative X or something like that. Rel tile X. Yeah. We have a bit of a naming problem. We'd have to think of, it'd be nice to think of better names for a couple of these things because there's like which relative are you talking about relative to what, and you don't want things to get too verbose, and yeah, it's always a bit of a struggle to name.
Yeah, because, well, that makes perfect sense because we get the chunk out and then we say, okay, we have our chunk now. Let's look at the actual tile that we care about. Like you could say this, like is world point, instead of is world point, is world tile empty, and then this would be is chunk tile empty after you get the chunk out. I might like that naming scheme better.
Things properly. All right. So now we have a problem, which is that we have to actually do something, which actually has one of these. We're basically saying it's 256 by 256. So that makes it a little bit harder on us. Of course, what we could do, and is what I'm going to propose we do, is just weld these together for now and just have one that we can store. That's a 256 by 256er. So here we go. I'm going to just go ahead and do that. So this. Oh boy. I don't know. This is a bad idea. I'm sure this is a bad idea. I probably shouldn't do this. I really want to, though. All right, let's take a look. Let's see what happens if I do it. You ready for this? This is just stupid, and I apologize ahead of time for what's about to happen. It probably won't work, but I'm going to try it anyway.
Hold on, I missed this. I got stuff mixed up a bit. Integers less than 2 to the 24th power are, in fact, exactly representable. So int math.floor of x probably does the right thing for those values. It looks, at least right now, like we're only interested in 8-bit and 24-bit integer values, so we're good. Sorry for all the headache. Didn't mean to bring that up again, but it felt irresponsible not to. No, I mean, I think it's important to be aware of that, because I wasn't before. I was just kind of trusting that, when we were dealing with, even with those smaller integers. So basically what you're saying is that once the integers get to a certain size, and that makes more sense to me because you're trying to represent bigger and bigger numbers with, 32 bits in floating point versus int, and it makes sense that as you get to bigger and bigger integers, that's when you start to get into, these tricky situations with doing math.floor. I would probably argue that it's still better for us to do things this other way, right? Like you're suggesting, which is truncate to 0, subtract 1 for negative values, or, and if it's a positive value, you can just truncate towards 0 with the cast, right? So good to be aware of that fact, but still we want to not put ourselves in a position where someday far away in the future we do care about bigger integers and then we have forgotten, right? Like it's good to be aware of, and it's good to implement something that would work for bigger integer values if we needed to, I think. So yeah, I'll keep chewing on that too. But I still think it was a good conversation to have. And, those are the tough, that's where like the rubber meets the road as far, like right now, this is not I can recognize that the work we're doing to just get a bunch of, tile stuff together, not being the most exciting. It's not the toughest problem. It's a bit of a headache to like reconcile, like, the notion of the game world and all these chunks, and then like which chunk are we on, and then which tile are we on in the chunk. It's not a super sexy problem space, but we'll get there. We'll get to the more and more fun stuff to look at on stream. It gets cooler and cooler the more things you start throwing on that start making things look like a game. But sometimes the problem that you wind up spending the most time on is has nothing to do with any of that. It's just like this issue dealing with like what's actually happening here when we cast this float to an integer. We want to make sure we're doing the right thing. Like for example, I'm in the middle of dealing with a very evasive problem where I'm trying to deal with some external API. I want to pass in a key that the API will then go and create some blob thing off in some server. And depending on whether I string interpolate that key in as the parameter that I'm passing to the API call, or I assign that interpolation to a variable before I pass it in, is giving me a different result. And I've done this like 24+ times now, trying to figure out why the same input is creating a different output. And the output is just that the thing is just the blob is not being written out to S3, right? In this case, for whatever reason, and I trust that it's most likely that I have done something terrible that has put me in this position, because I wrote a bunch of code that kind of decouples the API call so that I could mock it and then test it without having to actually call it when I run my test suite, right? Like all this fancy bullcrap that I have to do just to be able to quickly, run my test suite without having to actually make those API calls. But mocks they come with all these caveats, right, that make testing with them not the most reliable at times. But the point is, that's like a really annoying technical problem, and I don't even understand like what the implications of it are yet. Like, why would interpolating it? Like, I want to believe that I'm just doing something very dumb, but I've looked at it so many times now. How can interpolating the string while you're passing it in versus assigning that to a variable and then passing that in cause a problem? It makes me feel like there's some kind of weird type issue happening. Yeah, it's not. It's the very opposite of fun. I've just been losing my damn mind over it for the past 2 days. I cannot make sense of why it's happening. But anyway. That's a problem for off stream. I do a fair bit of shell scripting, strongly typed things. Stringly typed things. Yeah, I see what you're saying. Stringly typed things are annoying. Yeah, it's just like in my head, I'm like, how can this thing? And then I'm looking at the outputs too. I'm actually looking at the body of the request as it's getting fed to the API call, and they're identical. I mean, there's some like dynamic stuff happening where I'm generating a random number to be, put into the string because I want to create a random key, right? Because I want it to be different every time because, a bunch of different blobs are going to be conceivably uploaded as part of this end-to-end, functionality that I'm trying to build. I'm just trying to build multi-image uploads. It's nothing really all that fancy or interesting. But I'm trying to build multi-image uploads, and I'm getting the upload just isn't working in one case where I assign the interpolated string value before I pass it in, versus where I do it like in line with the call to the API. So it just makes no damn sense to me at all, and I'm really upset about it. So not fun at all.
Okay, here we go. Record keyboard macro, comma, space, space, Alt W, Control space, end of line, back up, delete, go back down to the next one, come here, paste it down to the previous row, there we go. End recording. Doot 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 doot. There we go. Emacs keyboard macros, ladies and gentlemen, to the rest.
Okay. Well, I don't know how to do that in the way that he did it, but that's fine. That did look pretty gross. I think I can just do this, right? And then, well, I think he stitches the first two. Yeah, so he's basically just making all of the ones and zeros map to exactly the layout of the tile map. In the way that we see it on the screen once it gets rendered out to the frame buffer. So there's that, right? There's that first tile map on top in the top left and then in the bottom left. And now I think all I have to do is rip that. There we go. And then same thing over here. If I can properly highlight my stuff. And I think that worked. Well, I did something wrong. Oh, because I replaced, well, whatever. How do I want to do this? I just want to go back to here. There we go. Oh my gosh. I did it. I'm in the machine now. Binary, ones and zeros, everywhere I look. I'll never get out, ever. This is the rest of my life, staring at ones and zeros. Okay, so there's our tile map in one big 2D array, right?
We have now welded ourselves into a single tile. It is not 256 by 256, but C will fill in zeros there for the rest of them for us. So we just have a thing called tiles now, which is 256 by 256. At least I think C will fill in the rest of them for us. Will it? Or will it complain? It didn't complain. So basically...
I'm not going to be able to do that. So I guess he didn't get rid of these constants. Is that right? Let me just do that and then see. Yeah, so this is not going to work, I don't think. Out of bounds. Did he just change those values to 256 and I missed that? Is that what happened? Like that's the whole world, right? Yeah, so Odin is not going to neatly fill all of this in for us. How do I want to go about doing that? Becoming fluent in binary for our soon-to-be AI overlords. Yes, yes, ones and zeros, feed me. My mind goes to UTF decoding happening in one case and not the other or something. Yeah. Like there could be like a Terminator value, like cause so I'm doing this in Elixir, right? And Elixir has like char lists, right? And bit strings, and I'm not totally sure if there's really a difference between like a bit string and like a proper string in Elixir. So I have to go and chase down types in Elixir, and it's a dynamically typed language, which is almost assuredly causing me, you know, part of why I'm having these problems. But I've never had to deal with this before, honestly. And the same code that I'm using has worked for years, and all of a sudden today I'm seeing this issue. The last couple of days I'm seeing that issue. It's a miserable time. Okay. Yeah, how do I want to do this? Oh my goodness. I did not realize that have I been looking at Casey this whole time? Yeah, so I don't know if I was I not showing all of this as I was making this change. I'm so turned around now. But this is all I was doing, is just getting this all into this one 2D array. But again, I cannot do this the way that Casey's doing it because it will not zero out the stuff that I haven't already defined. So I could declare it, but then how do I just get the pieces of it defined that I want to define and leave the rest as 0? I can't for the life of me remember how I did this in Zig, because I'm pretty sure you can't do this in Zig either. What else does he need to do here?
We now have our world, and the world essentially just only has one tile set in it that's 256 at the moment, and we're going to have to just start with that, and we'll have to fill it in. We can make it bigger later. Anyway, so then we have tile chunks is going to equal our tile chunk here, which is this guy, tile chunk. There we go. And so yeah, you get the idea. And so tile chunk count.
Right, okay, so he defines this as one big tile chunk. We'll just let that sit there for a minute while we try to figure out how that can be done. And then this doesn't need to be, yeah, none of this is even going to be here, right? Because we're doing it all in one chunk. But then world, where even, well, I guess I had this all the way down here. We want to do that up here. Yeah. And so instead of, well, Yeah, he's not going to be able to just assign that right over. He's going to have to turn it into that pointer, which I'll do by doing this as a slice, but we need it to be 256 by 256, which, okay, so we're basically going to say that we have do we need, yeah, we don't even need to do, oh yeah, no, we still need this, I guess, to denote the fact that we have 2 by 2 chunks, I think. Nem set. I'm sure I could. I'm sure I could probably use whatever that would be, whatever that would look like in Odin, right? Like if we did, it would be like, well, if we imported, can I even do this? Am I allowed to import? Nope. I think I already discovered that I can't import. Yeah. So we could do this. The problem is just assigning the first, like, set of the space that we care about. But I'm starting to wonder if, rather than do that, like, rather than do this, I could just make it the size that I care about. Yeah, no, because, okay. Actually, can I just do this? Can only be used in conjunction with compound literals. Well, that is not going to do what I thought it was going to do at all. I thought I could just like implicitly be like, hey, just use the thing that I'm providing to the declaration to determine the dimensions, but that's not going to work. Oh dear, oh dear. Let's go back down here. Like this isn't right because we're not indexing into a 2D array of chunks. We're just indexing into one big chunk. But we could go just to the limits of the chunk that we care about, which would be just what we've defined here. What time is it? Still have a little bit of time, but I am going a little bit longer than I wanted to today also. Well, I guess I'm not too far. I'm not in too deep, but I do want to try and wrap up by 5. How much time is left in this? I would really like to sync up. Yeah, we don't have too much longer to go. It'd be really nice if I could just do this without actually counting. I mean, it would be just twice in either dimension. Like this was 17 and this was 9. Right? Like I could just do that and it'll work. Because that's all we care about. And Casey's just brushing past it because he doesn't have to think about it any more deeply. And this is not going to stick around anyways. Like we're not going to hard code the entire game world, obviously, right? We're going to start doing things procedurally, and it's not even going to be like a very interesting procedurally generated world anytime soon. So the point of going through this exercise and doing it would be to learn something that would be potentially good to know in the future, and I can't see why you would ever want to do things this way, where you're just going to say, like, I have, you know, the size of the chunk dim in 2 dimensions, 256 by 256, like he's saying. And I want to fill it out partially. Well, what I find weird is that he didn't change it on his end, really. Is that compound literal error implying that we're missing commas on the far right? I don't think so, because we do have commas out there. I literally do not know what that error meant, and I don't want to bother trying to figure it out. Not that I don't want to know what that means. Like, I want to be able to just do this and understand when I can implicitly define the length and when I can't. Like, I think if I was to do redeclaration, well, if I get rid of this, that works. So I can make it implicit in one dimension, but I can't do it in both. Like, that works. But what I was just starting to think here, and it just feels kind of like a pointless exercise, really. But doing it for the sake of doing it, just to see how I would do it. Again, I don't know why you would do this. I'm trying to think. At least in this particular set of circumstances. I don't know. I think I'm overthinking this, and I just want to try this notion that I have of doing it. Okay, yeah. So he defines these right here. I didn't see this, but if I go up here, right, he's saying that it's 256 by 256 here. I didn't catch that for some reason. It's right there, but that's why this is gonna work, right? He can say that this is how big I want the 2D array, and then you're just gonna fill it out implicitly. The rest will be filled out to zeros, but you can't do that in Odin. Odin will implicitly declare everything to 0, so that's why I can do this. You know, that gets me one step of the way. Whoops, I need to go back here. I can do this and say, you know, I want it all 0 initialized, which is fine. But then we want to fill out just the, yeah, so these are now 256 by 256. I don't know why I want to keep all of those around. I feel like it just makes sense to get rid of those and do this, chunk dim, chunk dim. But we're actually not going to do it this way, right? We're going to do this. We are going to slice into it. Yeah. In fact, that's much simpler than I was making it out to be, I think. Chunk dim by chunk dim. Well, no. I don't know what the size of this is, so I can't slice into it and then say, I can't say this, right? I need to know how much data this is before I can slice into it and say, assign the data here to be this. I mean, I know what it is. It's 34 by 18. Whoops, not 24. 34 by 18 is out of bounds. Oh. Right. We want this as, well, yeah. Well, I'd have to, like, yeah, shit. So, tile chunk buffer. I could call it a buffer. I want to say, give me this. Give me all the data out to the dimensions of the tiles I want to actually fill. And then Yeah, no, because I can't just say modify that whole slice, can I? Yeah, I cannot just assign to that whole window of memory in place like this. Like, I know what I need to do. I'm just struggling to think of the least insane way to do it. This Odin do stuff like tile chunk, index 0 to 34 or 0 to 18. Yeah, so like what that would do, right, is give me... Yeah, well, kind of. So I could index the first one, but I couldn't take a slice of the first dimension and then take a slice of the second. I'd have to do like what you're saying, what you typed in there. I'd have to do it like this: tile chunk 0, and then give me the extents of that. And then this would give me the first row of tiles. But I want to be able to just say all of this. I guess what I could do is say, give me the memory out to that. So I think this is what I can do. This is messed up. So we're gonna say we want a 256 by 256 tile chunk, right? But if we take the address of that and cast it to the dimensions that we care about, which is 34 by 18 U32. Cast it to that and then say this is what that is. This is what we want in that memory. Not an expression, but a type. Yeah. Cannot cast. That is that. Yeah, I mean, that's fair, but if I say I want the raw data, give it to me and give it to me raw. Still cannot do that. Wow, what a headache. $27, $28, $29. Did I index that wrong? First, oh, yeah, I think, is that right? Is it like this? No, you just cannot, okay. Damn. Well, I get, what if this is a pointer and then I dereference it? I think that's what I meant to do. Yeah, that's what I meant to do. And I think the way I was treating this is right. I think we're good here. Right, so this is nasty, and I don't need to do the raw data. I don't know what I was thinking. Well, now it's complaining again. Hold on. We still have an error here, so actually we're not good. What is that error? $33 is out of bounds. It was 18. Right, 18, yeah, 18 rows, 34 across. Okay. My bad. Right. Okay. So that is correct. I don't think I need to get a raw pointer out of it. So we're just going to take the address of the chunk, right? And we're going to say, give me the data up to the dimensions we care about. It just seems kind of silly because I could just define the chunk as being 18 rows by 34 columns here. I don't know why I kept on getting that twisted. And then we're just going to say, but for the sake of doing it the way Casey is doing it, right, I want to just say, okay, we've got the 256 by 256 tile chunk, and then we're going to take a reference to that, and we're just going to modify up to the places we care about. That took longer than it probably should have, but you know, it works. It's just it feels silly, but for the sake of doing it, right? I felt like I had to do it. Nothing but rags. Hey, thanks for stopping by. After you clear it, can you get a 2D slice of the right size to fill in? I don't know any Odin. Yeah, I was trying to figure out like the way to do it Odin-esque, right? Where I can just do like what I could have done is instead of trying to declare it or assign it in one big block, I could have indexed all of these as slices, I think. Yeah, so that I think that's what we would have done if we were to try and do it with slices. We would say tile chunk, and then we would go and like increment, you know, the row. Well, we would have just done it like this, right? We would have to get a slice up to the dimensions we care about. And then we would have taken each slice, and then we would have gone like, okay, we have to do all of this. And that actually just looks a lot uglier than just playing with the memory. Right, well, that's a good point. That's a really good point. So this probably won't work, right? Well, yeah. Yeah, I see what you're saying now. This actually will not fill out the tiles the way that we want. It'll just be a bunch of blank space. I mean, it'll work. It'll assign... because it's going to treat the way that we're assigning this memory to that pointer as being... or wouldn't it? I really don't know the way that this cast would work. I'm assuming that it's going to make it non-contiguous, right? It's going to get us 18 elements from the first dimension. I don't even know what the hell I'm saying at this point now. I guess we can just roll with it and see if this works the way I think it's going to work. Right? Because it's saying just give me the first 18 rows, and then give me the first 34 columns out of each row in memory. But is it going to treat all of that contiguously and then not actually write out the tiles that we think it's going to write out to? And then I'd have to use slices. I've already spent way too long on this, so I won't go any further. We'll just wrap it up, and then if I need to come back and change this to just do the simplest thing I can do, which is just define it this way, right? And not mess around with any of this stuff that I'm trying to do now. Like, technically, this cast and dereference lets us do the assign, but I don't think it's assigning the tiles that I think it's assigning at this point. The cast will get a contiguous 34 by 18 bytes of memory, which will not work. Yeah. I think you're right about that. But we'll wrap this up, and then we'll see how we can do that better.
X and Y, we only have one now. So there we go.
Oh, okay, because it's one chunk, one big chunk.
What is the problem? Oh, cannot convert between. Yeah, you're right. That's not what I meant to do at all, is it? That's a bad idea. So basically, tile chunk. We can actually say this is a tile. Well, no, we can't really. So we'll say tile. This is our actual tiles, temp tiles, essentially. So we'll just say here we have to define a fake tile chunk. Tile chunk. We're going to point that at this, and tile chunk tiles equals our temp tiles, and that should be.
Oh wow, what a mess. So he's saying this actually isn't the chunk. These are temp tiles. What the hell is wrong with my brain? It's that point in the week for sure. Typing things out of order. So we declare the count, and then we say we have a tile chunk that is a tile chunk struct And in fact, I'm just going to do this in one line. In fact, I should be doing this here, I think. I don't know how I get so out of order. But this should be up here, I guess. And count X and Y are just gone, so get rid of that. Tile chunk count X and Y. The chunk dim, move that up here. So dimensions of tiles and converting meters to pixels, and then the tile chunk over here. And we're going to say that the tiles in the tile chunk are temp tiles. In fact, will that work? Whoops. Cannot assign this because tile chunk is a slice. Oh. What? Yeah, he can't just do that. This would have been easier. The way we had it before was easier. We're like adding an extra step in here now, but so be it. So this goes out. You take a slice of chunk dim by chunk dim, and now you're telling me that's wrong? Damn it. My mouse wheel strikes again. I can't scroll up. Fine, 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 fine. Oh. Yeah, I didn't even bother. Okay. You missed a step, James. So we need to turn this into a multi-pointer of not tile chunk, not tile chunks, but U32. I think this will actually just work like that, but I was missing the rest of this here. And I think that works. Right? What's this warning about? Expected to type. What do you mean? Oh, that's because that is not how you define a multi-pointer. God, what is going on here? That is not a type. Well, it helps if you do this. Wrap the type in parens, and well, what is this now? A slice of tile chunks. I think we are all sorts of twisted up now, because he defines one tile chunk, and he says those are the tiles. I think it's just because this is now that. Well, it's a pointer to that. Right? Okay, never mind. I was saying that this is all, like, we're adding this unnecessary, like, layer of, like, the world has a tile chunk, and then the tile chunk has the tiles, but you could just have the world have the tiles directly, and then this is now just a single chunk. Okay, that works, finally. And now we have some other problems. I think I'm just going to call that chunk probably. Yeah, this is like the mother chunk here, and then we're getting an individual chunk out of this call. My brain keeps going back to thinking how we're going to deal with that stupid 2D array. Column doesn't it? What is this? Game state player P has no field tile chunk X. What did we do with those? Yeah, abs tile X and abs tile Y now. So I think this would just be abs tile X and Y. I mean, we don't even need to do this because it's already going to be zeroed out. And then this is going to change to rel tile. I'm thinking that I'm just going to remove these assignments here because it should all be zeroed out anyway. Wait, what? World. They are still tile rel X. See, this is what I was talking about earlier. We have tile rel X here, but then if we go to chunk, was it chunk or was it tile chunk position? It's rel tile over here. Rel tile over here. Tile rel over here. No. You can't do that, Casey.
Better. What are you complaining about? Oh, right. U32. Sorry, we got to cast that because it's a two-dimensional array, which doesn't like. All right. So we got that out of the way already. Tile map X, tile map Y. So this is now, they're just on tile 3-3. They don't need to know that anymore. So we basically just have that. We've got the tile map that we're on is just going to be, to get the tile map for the particular player. So we can do that the way we're doing it here. And we're going to, where do we actually use that tile map, though? We don't use it. We're going to.
Oh, he does sign. Okay, I got this backwards. So that other, yeah, because we're collapsing them to two members, we don't need two of those, but we do need to keep these assignments because those are the members we're collapsing them down into. And I can't recall why, but we're assigning those to, we're assigning the tile rel to 5, which I cannot say. Well, I guess it's saying we want to start 5. No, we're starting at, okay. Well, I can say what this is, what these assignments are doing. I'm at that point in the day where I can't even speak in complete sentences anymore. We're going to start off at abs tile X and Y, not abs tile X and X. On the third X tile and the third Y tile. And from within that tile, we're starting at relative X and Y 5. Okay, fine. Easy enough.
Where do we actually use that tile map, though? We don't use it till down there. So really, let's go ahead and make this super piggy for now. Maybe, I don't know if I should put the pig hat on. It's possible that the pig hat should go on for this, but let's take a look. So really, the only thing we have to do now is update our drawing code, right? Because our drawing code is wrong. And so our drawing code has to be able to draw a tile map. So what I could do is just literally do a get tile function. In fact, I'm going to put the hat's going on. Because this is super piggy right now, what's happening. This is going to be super inefficient, but it's probably the right way to go just to test that things are working as we go forwards. So I'm going to make a function here, like isWorldPointEmpty, right? I'm going to actually make a thing that just gets the tile value, right? And so I'm going to do something that's essentially, I'm going to change this, is I guess what I'm saying. I'm going to change this to something that's like UN32 get tile value, right? From a can pose. It'll do this, and then instead of is tile chunk.
Oh dear. Who could have known there was this much code to write at the end? Get tile value, right?
Tile empty. This guy right here. Instead of that, I'm going to change this function around to basically be get tile value, right? It's going to be this. It's going to be get tile value, and it's the checked version, right? And so instead of having the empty here, we're going to move the empty down. We're going to say, okay, we've got the tile chunk value. We'll assume the tile chunk value is 0 if we couldn't find anything. There, we will return that, the actual value, and then we'll make this guy.
Okay, so he's overloading some stuff here, which is just going to confuse matters further for me. Great. So there's getting the tile value out of the world, and then there's getting tile value, and then he still has this unchecked proc, at least I thought. So is tile empty? He renamed that. Yeah. Okay, so this is where we were at here. So there's getting the chunk, there's getting the value out of the world using the world position. And then there's getting the tile value out of the chunk using the X and Y on the chunk. This is where having this big old font is really hurting my cause. Okay, so yeah, get tile chunk, get tile value unchecked, is tile empty, becomes get tile value. My indentation, no!
Value, and it's the checked version, right? And so instead of having the empty here, we're going to move the empty down. We're going to say, okay, we've got the tile chunk value. We'll assume the tile chunk value is 0 if we couldn't find anything there.
Tile chunk value, just a 0 to 32, U32. If our tile chunk is not nil, and then he got rid of this, got rid of all of this. So I'm just gonna trust that he knows what he's doing there and do the same.
We will return that, the actual value, and then we'll make this guy.
Okay, well that's pretty straightforward. Get tile value unchecked. Oh, we're not instantiating that there, so there you go. And then instead of returning a bool, yeah, you change this to be U32. Sounds good, sounds good. Okay, I think that's good.
Is world point empty.
Oh, and then, so wait, now we have we have get tile chunk. No, that's not changing. Is world point empty? Yes. Okay, so we have this re-declaration here. How do we want to change these names so that we can do this? Because we can't use function overloading in Odin. We could just say from, get tile value from world position. That's pretty nasty long. And we could also say, let's go to that other. Proc. So this gets it out of the chunk. Didn't I have another? So there's get tile value unchecked. There's get tile chunk. What if we said get chunk tile? And we said get world tile. And then this is going to change here. But he still hasn't updated that, right? I think is world point empty is going to go away. So I don't think I need to worry about that. And this is almost certainly going to return the tile value. So it'd be U32, right? Let's see where it goes with this.
He's actually going to do that empty check. So what he'll do is he'll basically say that this is that value there, right? Empty equals that. And so he'll say tile chunk value
okay.
Equals.
So that is not going away. Because we get the tile chunk value. Yeah, fine. I really want to just call it tile value, or even just tile, but then we say empty is 0. Well, tile chunk value equals 0. Equals 0. Can't even talk now. Oh man, I shouldn't have spent so long trying to figure out what to do with that 2D array. That was a mistake. Cannot convert untyped value 0 to... Oh, I have to dereference it.
Get tile tile chunk value. There we go. Well, get tile value. There we go. So he'll pass those. He'll get the tile value.
Yeah, he's going to get tile value, but this is get chunk tile, right? Yes. Yes, yes, yes. Oh, because I'm comparing the tile chunk, not the tile chunk value. Duh. And we're redeclaring empty, which we don't want to do, so we'll just declare it there. Okay.
Do the check that's empty, and that way I can now have a thing that does get tile value with a can pose, and that can pose will then pass it directly back to the user, right? Tile chunk value, and similarly, I guess we can just reuse this now. So basically, this.
So that new get world tile here that changes to just get chunk tile underneath, and I don't think we need this empty here. We can just say tile chunk value. These do like remarkably the same thing. I see what he's going to do. He's right about to have this is world point empty call this get world tile proc. Okay. At least I'm pretty sure that's what's about to happen. Let me turn this tile chunk value. Looking good.
This can just be called in here.
I suppose I should probably break this up, but I'll wait for him to kind of wrap this up before I start making this less wide. The code is very thick right now.
Here directly, so I don't have to have two of those, so we can just go ahead and collapse that down, right, like that.
I barely missed, but, well, I was correct in my assumption that all of this goes away. Yeah, he passes in the canonical position or world position to get world tile. And now, yeah, we'll just split this up so it's not so wide. Still pretty wide, but at least you can see everything. That's feeling pretty good.
I have two of those, so we can just go ahead and collapse that down, right, like that. So what we can do now is we can just say, all right, well, we want to view on the screen. We basically want to view. In fact, we could even say we want to view wherever the player is at the center or something like this. Yeah, I don't know exactly how we want to say that. But basically, if I just draw the 9x17, what I could do is just say get tile value, and when I call get tile value, I just pass it the row and the column for the absolute ones, and I don't have to pass tile map at all anymore, and that would give me exactly the value. Now, we don't have yet where in the world we're looking at, and so that's the thing we'll have to do tomorrow. But get tile value, what does get tile value take? Get tile value takes a can pose. So what I'd like to do here is make it so it doesn't actually need a can pose as well. I'd like this guy to just take an abs tile x, abs tile y.
Okay, so we actually have to go and say get world tile, or get tile from world. Maybe, now that I'm looking at this more, might wind up being the right way to go there. Abs tile y. 232s, right? And then you don't need that whole thing off of there, and then this can just call that like that. Indentation, the hardest part of programming sometimes.
Now, of course, we might want one that actually takes can pose as well. Abs tile x, can pose abs tile y, and we may want to, yeah, we might want to change some of those things and so on, but for now.
What else do we got here? Why are column and row? Oh, okay. Yeah, because those still aren't. Yeah, so this just doesn't work at all because we don't have this now. So I guess I'll just hard code these the way he has. Is that right? Yeah. And we're passing in too many arguments here, so I think that fixes that. Cannot assign value row. Yeah, because these want to be U32s. And now I just don't think that the player position has these values, does it? Yeah. I think it's like that. But these have to be compared as ints, I guess. Sure.
There we go. Oh, Q&A. Yeah, not enough time in the day sometimes, people. All right, anyway, what we're checking with here is these, and that's fine. We've got a few more things to do. Signed, unsigned mismatch. That's fine as well. There we go. Lower left X, lower left Y. Yes, they are not a member of the world. That is true. They are now just members of this routine because they don't actually have any meaning anymore in the actual
So I guess he either worked through a bunch of this stuff already, or I was doing a poor job of, whoa, keeping up. But this stuff down here, we'll just see if I can do this right off of my own understanding of what's going on. So tile side and pixels, that's going to be the absolute tile. And then over here, well, we can't multiply these out by each other because that's an int. One's an int and one's a U32, so kind of nasty. Because now that's going off of the screen. Where the hell is this? 375. Tile chunk X and Y. Oh yeah, I just blew right past that. What does that take? Abs tile X and Y. Yeah. Why? Why? Oh, abs chunk. Yeah, that's not right. I said it. I didn't type it. What is this complaining about here? Ooh. Wait, what? Unbelievable. Okay. Result has no... Oh, okay. So world position is just abs. Tile X and Y. We're getting there. We're getting so close. Tile chunk dot tiles. Is that right? Cannot assign value. To pointer U32. U32 and int. So for the index, I think we can just do that. And then for these tile chunk X and Y, those are U32. So what are these? Those are all ints. So at this point, I'm just trying to do whatever I can to get through this and get it to compile. Tile chunk X and Y. I cast the wrong thing. So what did I just say? This is a U32. Cannot assign. Does this mean that I just don't need to take the reference here? No. Tile chunk is a pointer to a tile chunk. Oh. Oh, what is going on with this proc here? Because there's just one big chunk. It's not... We're not getting at a slice of tiles in the chunk. Oh man, I do not understand. Okay, he's getting an... Oh. Okay. Oh god. So this is a slice of tiles instead of a pointer. And he's just jumping to the address of the tile chunk that he cares about in here. Which means rather than doing this, right, I think, well... Oh yeah, yeah, we're getting into some messed up territory with this one because I can't just go to the address of... And he's still calling it tile chunks. Yeah. Oh, that is messed up. I don't think I needed to go back this far. Where is that get tile chunk function again? How can he be indexing into tile chunks the way that he is? If tile chunks is just... a wrapper around the pointer to tiles. That's breaking my brain. I must be just reading something very wrong here. But it looks like it just works out for him. It is right around here when he collapses all of those tiles into one big structure. Yeah. How is he just able... Well, I guess it makes sense because at the address of tile chunk... Yeah, okay, never mind. This was breaking my brain. Entering some fuck shit territory. I was just thinking too hard. about this, but basically he's able to index into this struct just by using the because he's just using pointers, right? He's just using the address of where this starts, and so that's why he's able to just index it like this, right? Because it starts where the tile chunk member starts. He's still calling it tile chunks, but it's really just one big tile chunk right now. But he's indexing into it, and because the start of the memory of that member is also the start of the pointer to tiles, he's able to just grab it out like that. And so I was like, how can this possibly be that he's doing this? But of course I can't do it that way. That's like the observation I was making before I just, you know, went on this tangent for about 5 minutes trying to figure out how the hell, you know, how did I get to this point where, okay, I understand I'm gonna have to get out a slice, get out a specific part of the slice, but oh boy, okay, so so I think what needs to happen here is we just do this. Right? Yeah. So we say, here's our tiles member off of the chunk. In fact, does he do that much at least when he goes and pulls that out? I guess it doesn't matter because it's all just pointers in the end, right? He's saying, whoops, you know, at the same place where the memory of the tile chunk starts. But again, we just cannot do that because we have to work with slices. So I think this is right. I want to say this is right. We got a runtime assertion here that we're tripping. What is that assertion? Oh, great. Thanks for letting me know, compiler. You don't even want to tell me what the issue is? Well, I guess I know what line it is, so. Assert that the chunk is not nil. So we're just grabbing out a nil chunk, which is obviously not good. Man, oh man. That went bad. That went very bad. So, what does he do here? I'm just going to mute him so that we don't hear him jumping around. Oh, maybe I think he just got rid of this call entirely, and that's what I missed. Because where do we even use that, right? Where does that even get used? Now we got a different assertion that we're tripping. What? We haven't changed anything before this call, so how can this be tripping that now? Well, I guess it probably goes through once and then, yeah. So somehow the size of the state, that doesn't make any sense in the world position that we're storing. That doesn't make any sense to me. What on earth did I do here? Still not getting anything useful out of that. So, well, I guess because I'm not getting the output of the build.bat. Maybe that's why. Like, it's not... Is there anything in there? No, there is nothing there. Okay. Well. I don't think I'm going to be able to chase this down because that is a nasty one. I have no earthly idea why I'm tripping that assert. Things went very wrong for us at some point here. probably just going to have to take the L and call it, because at least we're, like, trying to compile now, and I'm not dealing with, like, where does this, you know, what does this call use now? What does that call use now? What do we cast this to now? Lots of messy changes, and I went on too many tangents and broke my train of thought, but it was good. This was, like, a more challenging stream for sure, and I was counting on this happening at some point, because I knew I would have to, like, break through like a really challenging place where I did something completely fucked up, and that I would have to go and chase down the issue. But it's okay. I can kind of suss this out and figure it out and come back. It's just never a good feeling. Like, how on earth can this be happening? That I'm getting a size of game state here that is somehow bigger. Like, there's just no way. Maybe this assert is just wrong, actually. No. Yeah, no. Well, the permanent storage size has to be bigger. There's just... What in the world is going on? What happens if I mute that assert real quick? We're just seg faulting somewhere. Is it because of the way I'm doing this right here? If I just do this like I probably should have done to begin with. Does that work? Nope. We are still tripping this. What the fuck? How did I do this, dude? I have no idea how this happened. That's incredible. Well, I will figure out what caused that, and I will be back maybe tomorrow. We'll see. There's a lot of stuff I got to get done around the house this weekend, but if not tomorrow, then definitely Monday. I'll spend some time thinking about all the things we've talked about on the stream. There were a couple different places we got kind of sidetracked on, but I think it was all worth it. And like I said, I was kind of counting on this happening at some point where I would just do something so bad that I got completely stonewalled by something that I have no idea how to begin fixing. Like, that just makes no sense to me that we're tripping this. There's no way. Like, it means that we're doing something messed up to the memory, right? It means that we're saying that the permanent storage, we're like assigning it to 0 or something. Maybe, like if I go, yeah, we didn't change anything in main, so we're not changing, we didn't, how can that be? I just want to throw in a print statement real quick. Game update. And see, why on earth print memory dot permanent storage size. Like, let's just print them both out, right? And see if this is actually what's happening. If we're somehow wiping the permanent storage size out and saying that it is 0 and therefore the game state is somehow bigger than that. That's just wrong. So I think the compiler is just telling me something incorrect. I've messed up so badly that I broke the compiler. Because this assert right here is, well, let me make sure I'm actually going to the right line in the right place. That is in the game. Yeah, so it's in the game. It's at line 314. It's this assert. we print out the size of the state, we print out the size of the game memory, and it says that the state size of the state struct is 16 bytes, right? And then this is the size of the game memory. So that's definitely not, it's definitely not the case that the state is somehow being made bigger than the memory's permanent storage size. It's just I did something very wrong that is tripping up the compiler such that we are having this problem. Very, very odd indeed. But I'll figure it out and I'll be back. Thanks for hanging in there with me. You know, it's a bummer to have to take an L and end with the project in such a sorry state, but we'll figure it out, and I'm looking forward to whatever the hell the explanation is. I'm sure it's something really small and subtle that, you know, I just wasn't paying attention, or maybe Casey did something and I just like skipped right over it. I got really messed up with this stuff, right? Having to name these things differently, because we have get tile chunk and then we have get chunk tile, which, looking at that now, you know, those two names don't feel good. And then get world tile. There's this check here to see whether our world whether our chunk tile is, our tile chunk value is empty after we get the tile out of the world. But like, why would any of this trip that assert, right? Why would any of these changes that we made have anything to do with that assert? It makes no sense to me. So anyway, thanks for hanging in there with me, and I'll leave you in suspense until next time when I figure out what on earth I have screwed up so badly. Have a good rest of your night. And if I don't see you at all this weekend, if I stream at all this weekend, it'll be tomorrow. Definitely not Sunday, because we got stuff going on Sunday. But if not tomorrow or Sunday, then Monday. So I'll see you then. Take care.